Hi there, and welcome to my course, SQL for Newcomers. I'm Sameh Sharaf. I'm a data engineer and have been working with relational databases since 2010. In this course, you will learn how to use SQL. Whether you are a student or an employee who needs to work with databases and need to learn SQL and add it to their resume, this course is definitely for you. SQL is a standard language which is essential to work with all popular free and commercial relational databases. If you learn SQL, you're able to use any of those products you see here. This course will use PostgreSQL. Why? Because it's open source, so it's free. It proved to have the best quality performance comparing to other open source relational databases available, and it has good documentation with great explanation for each keyword and function in SQL. If you need to learn more by yourself after this course, it will be quite useful. Okay, without further ado, let's start and hope you enjoy the journey. Happy learning! Okay, let's start by getting and installing the needed applications to begin this course. What are we going to do is, we're going to install a relational database manager or an RDMS like PostgreSQL. Why using PostgreSQL? Well, it's because it's open source, so it's free of charge. It proved its performance and quality comparing to both free and commercial RDMS systems that we have today. And it has a better documentation in case if you need any help, you can simply look into the internet. And there is documentation on its website. Next, we're going to use a SQL editor in order to connect, run, and execute our SQL scripts. What we are using is SQLlite. It proved to be good, it's free, it's open source, it's light, and it has many features that we can use in this course. So let's start together and download and install those two applications. Let's start by downloading PostgreSQL. From Google, I'm going to type PostgreSQL. Here you go. I'm going to check downloads, and from here you can see that PostgreSQL supports multiple operating systems, including Linux, Mac, and Windows. Since I'm using Windows, I'm going to check Windows tab, and from this page you can see what PostgreSQL version is available at the time of this video. It was 10. And as you can see, for version 10, it supports the following 64-bit and 32-bit for those platforms. In case you don't know which Windows version you are using, you can go to the top of the desktop from My Computer or this PC icon. You can choose Properties. From here, you can see what system type do I have. So, you choose which version of Windows you need to install and download. For me, I have 64-bit operating system, so I'm going to choose this the next time I'm trying to download PostgreSQL. I'm going to download the installer now. And it will direct me to a new page, which is the EDB PostgreSQL project. From here, I will choose enterprisedb.com, which we can download PostgreSQL, and I'm going to choose my version, which is 10.1 for this course, and my operating system as Windows 64-bit. Click Download now. Okay, my download is ready, and here is a double click. Next, I will download it into the default directory. I'm going to keep it at and next. Here's the directory where your data will be stored. In case if you uninstalled PostgreSQL in the future, you'll still find your data here to be restored later on. I'll keep the same folder. And here is going to ask us for the super user we're going to use in PostgreSQL. Since we are doing all tasks on our local machine, we can't choose any password that we want. Later on, you should consider a very powerful password for yourself when you need to launch any database in the future. This is my password. I type it again. Then next. Here comes the port, 5432. Remember this because we need it later. I'll keep the default one and press next. Here's the locale. If you're using any language other than English, you can use it as your default language for your database. I will keep it the default. And I'll click next. Another next. And here we go. It's going to take some time, so be patient and I may speed up the video. My installation is done. Before that, I'm going to uncheck the Stack Builder option from here since we don't need to open it. I'm going to finish the installation. Here we go. We're all done with installing the database. What we need to do next is installing a SQL editor, which we need to connect to our database and run our SQL scripts. Now let's start with installing the SQL client that we can use to connect to PostgreSQL and run our scripts. From here, I'm going to type SQLlite. It is the editor that we're going to use. From the first link here, we will choose SQLlite and we're going to download the GUI version since we're going to use it on Windows instead of the terminal. SQLlite is an open source and free tool to use and it's available for Linux, Mac and Windows. I'm going to download the GUI and here it will show me the latest version. By the release of this video, I have 1.28. You can find this version based on the time that you are downloading and installing the SQLlite. From here, you can see multiple links for downloads based on your operating system. For Windows, you need to choose the exe file. For Mac, you need to use the DMG, and for Linux, if you're using Debian, it's DEB, and for Ubuntu, it's RPM. There is also the compressed files as well as the source code. We're going for exe, and I will select it and download it. After downloading the installer, I'm going to launch it and waiting for it to be finished. And it's done already, and we're going to see the logo. Nice. Alright, we installed SQLlite for now. Let's see how can we connect to the database. In order to connect to PostgreSQL, we need the following information. First, you need the database user. We're going to use the admin user or super user called Postgres. This is the user which you define the password when you install PostgreSQL. Next, you need the database that you will connect to. PostgreSQL allows you to create multiple databases based on your needs. The default database we will be using is also called Postgres. Sounds easy for now. Next, the host. The host is the server which PostgreSQL is installed into. Since we installed PostgreSQL on our local machine, the server will be the local machine, which is localhost or the IP 127.0.0.1. Since localhost is easier for us to use, we're sticking to it. Next, the port, which we defined when we installed PostgreSQL. If you kept the default port, it will be 5432. If you change the port, you can use that as well. Let's see how can we put that in SQLlite. Back to SQLlite. Let's connect to PostgreSQL. From the Add button here, I'm going to click it. And from the information, for the name of connection, you can name it SQL course, or any name that you like. From the database type, we're going to choose PostgreSQL. And from the server address, which is the host, we're going to call it localhost. The port will be 5432. In case you change it, you can get your own. For the user, we're going to use the super user, which is Postgres, and the password you added when you installed PostgreSQL. Finally, the initial database or key space, which is the database that PostgreSQL created for us, which is Postgres. To test our information, we can click Test and see if it works. And here you go. Connections tested and successfully connected. Click Save, and here we have our connection ready for us. Click Connect, and you are all good. If you see this, then congrats, you're connected to PostgreSQL. Your machine is all ready, and we can start the course. Okay, after we prepared our database and we installed PostgreSQL on our machine, we need some data to experience on and learn in this course. I've generated some random data to use it in this course. You can download it from the attachment in this video. You can find an SQL file. And after that, I'm going to show you how to import the data into your database. Let's start by opening SQLlite. Next, connect to your database. Alright. From here we can go to File and up to Open Query. From here I'm going to open the file that I downloaded. Here we go. Here are the file, and those are the scripts that we're going to build our database, our tables, and the data that we're going to use in this course. Don't be scared if you don't understand what is that. We will learn all this eventually. What are you going to do now is you can simply click Execute. Here you go. When it says query run successfully, all this means that every query or every script is written here has been run and done successfully, and seems everything is working and all is good. But you can notice it's when you go from here and you click on the right click on your button on Postgres and refresh the database, you get to see it here and a folder or directory called public. This is the default schema for Postgres. When you open this directory or schema, you can see two tables, departments and employees. If you can see those, it means that you could successfully create the data that we're going to use in this course for now. Alright, let's move to the next section. Some students who are using Windows 32-bit are having problems with SQLlite since it only supports 64-bit. In this video, I'm going to show you how can you download and install an alternative SQL client called dbeaver, which supports 32-bit Windows. From Google, I'm going to type dbeaver, and it's the first link. You can directly go to dbeaver by dbeaver.io. From here, I'm going to go to download. I'm going to choose the community edition since it's the free version, and I'm going to choose Windows 32-bit gonna download it and wait for it until it's being done. And from here, I'm gonna use English. You can use any language that you feel comfortable with. You agree. Choose which computer, choose mine. We'll ask again for the language for some reason, and we're gonna go to agree again. Here what you need to do is you need to choose the dbeaver community version and along with the GRE. The GRE is used by the SQL client dbeaver since it's built on Java. Keep those checked. And here you can specify where to install it. Here, if you need any shortcut, and you can say you don't need any shortcut if you don't want to, you can install and wait for it to be done. Your machine may take longer time since my machine is powerful. Not bragging, of course, just like to make sure that if it's slower, it's okay. And you can create a desktop shortcut if you want to. After downloading and installing dbeaver on our machine, I'm going to open it. So the first time you open dbeaver, it may ask you to download a sample dataset or a sample database for dbeaver, so it's free, so you can play around with it using SQLlite. We don't care about that for now. What we care about is connecting to Postgres. So from here on the far left you can see new connection. Click on it and you'll see the databases that dbeaver supports. So from here what we want to do is PostgreSQL. Not the old one, but the new one. Can go next. And here you can see the default values for the configuration for connecting to PostgreSQL on your machine. If you didn't change anything, so you should see that the host will be localhost, the port will be 5432, the database will be Postgres, and the user will be Postgres as well. So if you didn't do any changes while installing PostgreSQL on your machine, those configurations should be sufficient. Now you can provide the password. And if it's all good, you can test the connection. Since I tried dbeaver before, when you test the connection the first time, it will ask you to download a number of libraries for GRE that is necessary for dbeaver to run. So instead of this pop-up, you can see a window which will show you the libraries and it will ask you to download those. You can just click on download and all is good. Now my connection is success. I'm gonna say finish. So after that, what you're gonna need to do is you need to download the dataset that is attached in your video here or in the previous video. So after you download it, you need to open it from dbeaver. So you say open file. So based where did you download it on your machine, you need to open that file. Here's my file here. Here's a script that you need to run in order to have the dataset that we need to work on this course. I'm going to select everything. You can do it manually, or what you can do is press click Ctrl and A. After that, you can click on the execute button here, or you can press Ctrl Enter to run this. It should be all good. To make sure that everything is fine, you can go here into the connection. You can choose Postgres, you can go to schemas, public, tables, and you should see two tables, departments and employees. If you want to run or open a new file for you to work on, you can say new, and you can select only a file here. You click next, and then here you need to choose general as a folder, or you can create a folder if you want. And next you can name it. For example, I will name it test or exercise 1 or lesson 1, whatever you like. And most importantly, you need to call it .sql in the end, so the dbeaver can recognize it as a SQL file, so you need to run queries. If not, it will show you like a blank file, and yeah, it won't show you the needed execution buttons to run your queries. I'm gonna click finish, and here's a new page. The old page is still there, so the cool thing that you can open as many tabs as you want, so you can work on several pages or several files, and each file can have separate exercises. So I'm gonna show you how can you check if the data is good. So select star from employees. I'm gonna run this using either this or Control Enter, and you can see the data from here. Here's the grid, and here's the data that we have. You can go around and you can see the data. Well, dbeaver gives more features than SQLlite. SQLlite is quite light comparing to this, but yeah, on the other hand, dbeaver is a bit more complicated for starters. Anyway, you'll take ahead of this. Just take your time, and you can see it's quite simple. It's not that difficult. As long as you reach this level and everything's fine, congrats, you can work with us now. You only need to write your scripts from here. You can execute it using this button, and yeah, you're good to go. Thank you very much for watching. Okay, so now we're going to start learning SQL. First thing I'm going to do here is I'm closing this tab. We're going to start fresh, and I'm going to maximize the window so we can see more. We're going to start together with learning SQL by learning the first statement we need to know. The first statement is called select. What select does, it gets the data that we need from any table that we want, or any query that we require. So select is the main statement in SQL. That we're going to do here is I'm going to show you how to use the select statement in order to get the data that we need from any table. Let's say employees. First, from the editor, I'm going to type select. It is where PostgreSQL can know that get me all the data that I need from the employees table. After select, we're going to show here what columns that we need from this table. Since we have no idea of employees, I'm going to use the star, which is Shift plus 8. Select star means that get me all the columns from a particular table or view or any data source that I am reading from. We get to define what table we're going to read from. So we say after that, from. Then the name of the table that we need to read from. Now we have two tables, departments and employees is more fun for us, so we will start with that. I'm going to use employees, and I'm gonna type it. That's it. Here I'm telling PostgreSQL to get me all the data from employees table, with all the columns from this table. Let's see the results by clicking execute. Here you go. What you see here is all the data in employees table. Please take note that this data is randomly generated. It's not real data. This is the setup we're going to use in this course, so we have the freedom to do whatever we want with it. So as you can see from the employees table, what we have here are multiple columns from IDs, first names, last names, addresses, states, zip codes, and phones, and other data that we can use later. A table consists of columns like the ID, the first name and last name. It consists of records or rows. Each row, we call it a record because It holds data for an entity. An entity can be anything, like an employee, a customer, a product, a vehicle, or anything that we can define to be an entity or an object to be stored in the database. So for each column and each row, we have a value. Like here, we have first name, like Ili or Joanna, which are employees. Those values of what we need most. When we need save, or when we query from our database. So we can see that we could select from the table. Alright, since that seems a bit big for us, if we can filter it, or let's say for now, we need to select only certain columns. Like, what I need to see here is the first name, last name, and phone of the employees. So instead of selecting star, here we can name the columns that we need to show and separate each column name by a comma. What you're going to do here is you type first underscore name, comma, last name, comma, phone. So here I selected 3 columns, first name, last name, and phone. When I execute this query, what I can see here is only those 3 columns that I defined in this query. First name, last name, and phone. This is cleaner. In case I want to see only the names of those employees and their phone numbers, this is the way you can do that. If you need to call them or connect them or share their information with the HR. It can be anything. Note that SQL is case insensitive, by the way, Means like, whatever character that it's being typed here, capital or small, it's the same and it doesn't matter. So don't worry about that if you type SQL queries. So I'm gonna show you how to type select in all caps and from in all caps, and you see that it returns the same results. For now, we can see the data that we need, or at least we can see the data that we want to work on. Have fun with that and see what data we have for now. We get to move on and talk more about how can we filter our data more and see only the particular rows that we want to report.
What is a database? A database is a collection of information set and organized so it can be easily accessed, updated, and managed. A relational database or a tabular database is a set of data organized into tables. You can think of tables as spreadsheets, but it's far more complex in design and can hold millions of rows. In order to access the data in relational databases, we use a language called SQL or Structured Query Language, which we will learn in this course. Using SQL language, we can access our data, we can update it, we can run various queries and get all the data that we need from the database. Databases can be used for various catalogs, such as sales, inventories, employee profiles, students' grades, and much more. Any data that you can store structurally, you can use databases. Relational databases are usually managed by a manager system or an engine, which controls database users' access and what can and cannot be accessed by those users, and groups as well as managing data reads and writes, hence the term Relational Database Management System or RDMS. Okay, before going into filtering our data using the select statement, we get to know something called data types. In SQL, we have 3 main data types. We have numbers, dates, and strings. Numbers such as salaries, commission rates, or prices are called numbers, and they are stored as numbers in the database. We have dates such as hire dates, which is the database calendar. We have strings. We call the words, the sentences, or any set of alphabet and special characters strings. Strings can be the first and last names, can be emails and job titles. They can also be phone numbers. Phone numbers are not numbers, by the way. They are considered characters because we type them in a way of a symbol pattern or format, like using dashes or spaces between the numbers so they can be recognizable and easy to read. When we want to filter the data out in our database, we need to make sure and take care of the data types that we are going to filter on. Sometimes there is a misconception between numbers, dates, and strings that they're not being used correctly. When some users filter the data in the database, they use unoptimized ways to filter the data. Or they have some problems how to filter the data and get the results that they need just because they didn't take a good look at the data they have in the table. So here are the data types SQL provides. We are going to take a look at how to filter based on those data types. Okay, your boss wants some data. Let's say your boss comes to you and asks you to get the data that he or she needs from the database. For example, they may ask who are the employees with the base salary more than or equal to $5,000. Maybe they want to fire them, or for tax purposes, or whatever. Anyway, next, they want to know who are the employees with the base salary between $1,000 and $2,000. Next and last, they need the employees with the salary brackets of $1,600, $2,700, or $4,200. We're going to see together how can we get the data for your boss. Let's go. Let's start with getting the employees with their base salary more than $5,000. Starting from the last select statement that we wrote earlier, we're going to see who are the employees who have such big salary. What we are going to do here is, after typing, select, then the name of the columns which we need to show and from which table we need to read from, which is employees. What we're going to do next is we need to filter the data. Means that we need all the employees with base salaries greater or equal to $5,000. In order to do that, what we're going to do here is we're going to type after the select statement where. After selecting from the table, we want to filter the data. So we're going to type where so we can define what are the filters or conditions that should be applied to filter the records of employees table. After where, we're going to set which column that we want to filter on. If you can see the data here, you will see that the column that is holding the salary or the base salary of those employees is called base_salary. So from here, after we're going to type base_salary, and take note that you should be careful about the column names. It's case insensitive, but doesn't mean you have to drop the underscore, for example, and it should be the same as what is it in the table. Okay, so after we type the column name, what we need to do is, okay, give me the base salary, which is greater than 5,000. So we want to filter those records. And to show the records with the base salary is greater than or equal to 5,000. So I'm gonna type the greater than sign here to say that give me all the data that the employees of base salary greater than 5,000, and I'm typing 5,000. So this query will get us the first name, last name, and phone from the employees where the base salary is greater than 5,000. Let's see what it gets here. I'm gonna execute it now. Here you go. You can see the employees with the salary or the base salaries of greater than 5,000. Cool. There you go. We could answer the first question. But if you can remember, your boss said that they want the base salaries of greater than or equal to $5,000.
So we want to also get the employees with base salaries of exactly $5,000. And so how can we do that here? So in SQL, there is a sign called greater than or equal to. So here I'm gonna type the greater than sign, and after that I'm gonna type the equals type. So here it says give me all the records from employees where the base salary is greater than or equal to $5,000. So in this case we covered or included the base salaries of 5,000. You can see that the number of rows have been different. It used to be 77 and now it's 84. So after I run the executed the query, we can see there is a difference. So we can look for salaries of 5,000. But since here we can't see exactly how much, and yeah, I should have added base underscore salary before. So I've added base underscore salary into the select statement in order to show the column and to make sure that the query returned the right data. And as you can see, all the base salaries here are greater than or equal to 5,000. As you can see, we have Gayla, which her base salary is exactly $5,000. So if I came back here and I removed the equal sign and I executed the query again, and you take a look, you can't find Gayla anymore, since her salary is exactly 5,000 and the query says we want greater than 5,000. So all the salaries here, if you take a look, it starts from $5,100 or $5,100. So it means that you can't find any salaries of 5,000 or below. Okay, so we answered this request now, and here we get the data, and here we used where, so we can filter based on the base salary. We use the sign, which we'll use to filter the data, either greater or less than, or smaller, let's say, from the value that we're doing so. And I'm gonna show you if I used less than or smaller than 5,000, you'll see that all the base salaries now shown is exactly below 5,000. You can take a look. Okay, if you used less than or equal to now, and I run this query again, you can check here if now we included the salaries of 5,000 again. So you may find Gayla again. I'm trying to find her actually. Okay, someone called France has a salary of 5,000. Okay, well, I can't find her. Okay, you can take your time to look it up for me. Anyway, so this is the data that we need, and here's how we can filter our data from any table. Okay, so what if we want all the employees where the big salary doesn't equal $5,000? Okay, so we have a sign in that in SQL. Actually, in maths, if you can remember, what we usually do to represent the net equal sign is that the equal sign with a dash on it. Meanwhile, here we don't have this on our keyboard. So SQL helps us do that by using the less than, greater than signs. Yeah, I know it's a weird sign, but this means that give me all the employees with the base salary doesn't equal 5,000. I'm going to execute this, and I'm going to show you that those are the employees with the base salary is not equal to 5,000. And you can take a look, and you couldn't find Gayla or France anymore here, since their salaries or base salaries is 5,000. And if you want to make sure, you can see that the number of rows here is 386. Meanwhile, if I can run the select statement from all employees without a filter, you can see that the number of rows will be more in this case. And after executing this, you'll see that the number of rows now is 393, which means that we have we have less records when we run the filter for not equal to 5,000. Okay, great. So let's move on to the next lecture. Going into the next request. Who are the employees with the base salary between $1,000 and $2,000? As we did before, we could answer the first request. Now we're going to the second one. Let's see how can we do it together. Going back to SQL Electron, now we're going to filter based on the range that we need, which is between 1,000 and 2,000. To filter based on a range in SQL, what we use is, let's say, a term or a keyword called between. What I'm going to do now is I'm going to use the between keyword after where, which because we need to filter based on a range, which is $1,000 to $2,000. And sure enough, we need to use the column, which is base underscore salary. This is the column that we're going to filter on, as we mentioned before. Now we're going to say that, okay, we need the values between 1,000 and 2,000. And as I'm speaking now, it's the exact same actually in SQL, as simple as that. So I'm going to type between 1,000 and 2,000. I'm going to execute this, and checking the data, you can see that the data that returned from this query is all base salaries of between 1,000 and 2,000, including the values 1,000 and 2,000 as well. As simple as that. We may not ask you to put a semicolon at the end, but I usually do that at the end of each query, because what you can do is, in the same document you can write more than one query and you can separate them by a semicolon, and you can run all the queries at a time, but you can make sure that they don't collide with each other. What I can do also to make the query cleaner is I can break the one query into multiple lines. So as you can see here, it's much easier to read. Here I can understand that, okay, select the first name, last name, phone, and base salary from employees where the base salary is between 1,000 and 2,000. The last request from your boss is, who are the employees with their salary brackets of $1,600, $2,700, or $4,200. This is simple actually, and with a simple trick we can filter based on those values. So let's see how. Okay, so we need to filter based on the three values: 1,600, 2,700, and 4,200. If you can look here, we see that we can't use any signs or any other arithmetic sign greater than or less than. They won't work in this case because here we're looking for an exact value. Even the equal sign doesn't work because it will return exactly one value in this case. So if I say base underscore salary is equal to 1,600, I will get the employees with the base salary 1,600, but I won't get the rest of values. And if I use between 1,600 and 4,200, it will get me all the base salaries of between this range. So this won't help either. So what we're going to use here is a new keyword called in. In databases, we can have what we call sets. A set is like a group of values which are different from each other, or we can simply say they are unique. And there is no two values in a set that is similar to each other, or they're equal to each other in this case. So as the same what we have here, we have 1,600, 2,700, and 4,200, which are all unique values or different values from each other. So in SQL, in order to get that, we're going to use a set. So we select the data from employees where the base salary is one of those values in this set. The keyword we're going to use here is in.
and I will show you how. This one, I'm going to delete those since I can't keep them here, but instead I'm going to use them here. And since we can filter based on base salary, what I'm going to say is I need all the data from employees with the base salary is in this set. I'll open the parentheses and I'm going to add those values. I'm going to type 1600, comma, 2700, comma, and 4200. I'm going to remove those because they will cause me some problems if I want to execute the query. So what I said here is give me all the employees whose base salary is either 1600, 2700, or 4200. So if I can execute this query and I will take a look at the base salaries here, you will see exactly those three values, 1600, 2700, and 4200. And you won't find any record with value or a salary other than that. Your boss comes again and they want to know who are the employees hired before 2005 and who are the employees hired between 2008 and 2010, as well as the employees who were hired on exactly 22nd of August 2010. How can we answer all those? Let's start one by one and let's see how can we get the employees who were hired before 2005. Back to SQL Electron, we're going to start fresh and let's select from employees table for now. Here you need to know which column that gives us the dates where each employee was hired. If you can take a look, you can find that hire underscore date is the column that we need. We're going to use that and we're going to filter based on hire date. How can we filter based on the dates here? I'm going to say here that typing where, so since we want to filter, hire underscore date. The first question was to get all the employees hired before 2005. Let's use the less sign and 2005 like this. And let's see what would happen if I execute this query. Oops, okay, we have a problem here. It says that dates and integers or numbers doesn't work in the filter condition in where clause, and since we're using the less sign, and the less sign is comparing between a date and an integer in this case. Numbers which are like 2005 are called integers in SQL. What we need to define here is we need to express 2005 as a date instead. So we need to express it as a full date, which is the year, month, and day all together. So if I want to come here and say that, alright, I need all the employees before 2005, what I mean is I need all the employees hired before exactly the 1st of January of 2005. How can we type this? First, for dates, we start with single quotes. So when you use dates, you need to use them between single quotes, so SQL can know those are dates. Next, you're going to say that we need all the employees before 1st of January of 2005. How can we say that? And how can we type it actually in SQL is we start with the year 2005 and then we type a dash so we can separate between years, months, and days. So since the January is the first month in the year, so its number is number 1. So I'm gonna type 1, it means that it's January. Then another dash and last the day, which is the 1st of January. So I will type 1 as well. So here I have the full date. So what we're saying here is give me all the employees whose hire date is before the 1st of January of 2005. Let's execute this and see the results. As you can see, it runs perfectly now, and we can see all the employees whose hire date is before 2005. We go down and we check the data, and as you can see, all the employees are hired before 2005. You can't find any employee hired after this date. Okay, so here's how we can deal with dates. And actually, sure, you can use the greater than sign if you want to look for employees hired after the 1st of January 2005, the same as we did with numbers. I will execute this again, and you will take a look at the hire date now, and you will see that all of them hired after the 1st of January 2005. If you want to include the 1st of January within your results, you can do the same with numbers in the previous lecture, and you can add greater than or equal to. So here's how you can include 1st of January as well. And actually, you can find data here that for any employee to be hired on 1st of January, because 1st of January will be New Year's Eve and it will be a public holiday, so it doesn't work actually. Anyway, what you can do also is you can exclude a date. So let's say that you want the employees who were not hired in 1st of January 2005. So you can use the not equal sign. Alright, so we answered the first question and we're going to the next one. Who are the employees hired between 2008 and 2010? Here, the same way we filter with numbers, we will do the same with dates, and we want a range, so we're going to use between. This will help us filter based on a range. If you go here, using the hire date as the column to filter on, and I'm going to type between, and I want to say that give me all the employees that are between 2008 and 2010, which means give me all the employees hired between the 1st of January 2008 until the 31st of December 2010, because we want to cover the 3 whole years, which are 2008, 2009, and 2010. We start with 2008 and January the 1st until, so we can add and, starting with the year 2010, and then December, which is 12, and finally the day, which is 31. Here we covered the whole year of 2010. Executing this query, we'll take a look at the data. Cool. So you will see that the hire date is between 2008 and 2010. I have a bunch of, okay. I'm looking for people hired in 2009. Here you go. Here I can't find one. Okay, so you see that we can sort the data in the future lectures. Here, as you can see, the data is a bit like randomly ordered. And what we can do in SQL, we can sort or order the data based on a certain field or column. You may ask, okay, why 31st of December? Because if you go and say, or type, give me between 2008, and 2010 with the 1st of January of 2010, and you run this query, you'll see that all the employees hired in 2010 are missing. Because what we did is we only covered the first day of the year 2010. Meanwhile, the year has 365 days. So that's why we had to cover until the last day of 2010, which is the 31st of December. You don't know how many people mistake this and they wrongly use filtering with dates. So be careful about this and keep this in mind when you filter dates. The last request from your boss is, who are the employees hired on 22nd of August 2010? I think this one will be quite easy for us. Okay, who is the employee or employees hired in 22nd of August 2010?
I'm going to delete all this first, and we keep filtering on the higher date, and I'm going to add the equal sign. And then single quotes. And here, since we're gonna filter on an exact day, we use the equal sign. I'm gonna type 2010, then August, which is 8, and then the day 22. Here we're saying select all the employees whose hire date is on the 22nd of August 2010. After I execute this, you will see that we only have one employee who was hired on that day. Now we want to answer those questions. We want the employee with the last name Alice, employees living in Florida, and employees with the phone number shown here on the screen. In SQL, it's quite simple to get such data, so let's find out. Starting fresh, we're going to check who is the employee with the last name Alice. So I'm going here and type select star, means to show all the columns from the table employees, where here I want to filter by the last name. So I'm going to type last underscore name. To look for strings in SQL, we do the same as we did for dates. We need to use single quotes. Here I'm going to say I need the last name, which is equal to, and open single quotes and then type Alice. I put a string of characters between single quotes because I will show you if I didn't use those quotes. I will execute the query to show you what happens, and you will see that SQL returned an error with the column Alice doesn't exist because it thought that Alice is a column. Let me fix this. I will add the single quotes again and I will execute the query. Here we go. We can see the employee. Her name is Jovita Alice. Please make sure that it's with SQL for strings, they are case sensitive. That means it depends how the string was typed, whether it was all capital or small letters. You use strings as they are in the database or the table you're doing. Here I fixed the O letter again to make it capital letter, run the query again, and you can see we could see the employee again. So now next what we want to do is we want to check the employees from Florida state. So since as you can see from the column we have state, which represents the state of the employee. So we're gonna filter on state is equal to FL, which means Florida. And we can see here now all the employees from Florida state. Sure enough, if I use the small letters here, you think that what results will I get is, sure, I will find no results, since Florida or all the states are represented with two capital letters. Next, we're going to look for the phone number provided for us. So since I can't remember the phone number, I'm gonna copy it from the notepad here and I'm gonna paste it. Since you can take a look and you see that we have the column called phone, which represents the phone numbers of the employees, we need to filter using the column phone. So I'm gonna type phone is equal to, and between a single quotes, since phone is a string, I'm gonna paste the phone number. Let's execute this query and we will see that this employee has this phone number. In the last video, we saw how can we concatenate
strings and numbers together. So what we can do is we can form new columns based on multiple columns that we have. For example, here we have the first name and last name, which are string columns. What we can do is we can convert them into one column, which can be called full name. As we did here, you can see that the first name and last name has been joined together to have the full name for each employee. But if you can check it out, the name of the column is a bit quirky. It's not a real name of the column. It depends on what ID are you using or what database are you using, so it can define its own column name in case you're showing a new column in your select statement based on several ones. But what we can do is we can choose our name for the new column that we have created. For example, here we can call this column full name instead of this quirky name here. How can we do this in SQL? It's so simple, and it's called an alias name. We can define aliases as a replacement or alternative name for our columns. So it's not about only creating the new columns based on the select statement, but even the existing columns, you can change their names in case they're not clear, or you want to export it as a report and you want more obvious or more clear names for your boss or for anyone that you're reporting to. So if you want to do an alias for this column and we want to name it full name, it's as simple as that. What we can do is after the column equation, let's say, which will create us the full name column, we will say as, which is a keyword to show that what we want is we want to name this column in a different name or a new name. So after as, I will use double quotes, and it's not single quote. Single quotes is for strings, but double quotes is for column names or for aliases. So here I will say full name. So what I did here is I named this column full name. If I run this query, you will see that the new name now, what we have, is full name. If you want to make sure that everything is right and to make it more clear, what I can do is I can choose several columns here, and I will show you that, as you see, the first name, last name, and full name. Full name is a newly created column that it's the concatenation of first name and last name separated by a space. And sure, to not mix things up, if I do select star from employees and I run this part, you won't find full name here, because what we did is we didn't create a new column and we didn't add it to the table. Just like the select statement, what will show us in this query that we run. So make sure that if you understand that select statement doesn't do any changes on the existing table. It just shows you what formulas or equations that you're doing on this data, which is a cool part about select statement. So you can keep the raw data in your table, and you can do whatever equations, whatever changes or transformations that you need to do so you can show the data, which is the powerful part of databases in general.
Have you ever wondered if you can order your records of your report based on a column? Like, I want to be in alphabetic order, or I want to sort them by ID or by the net salary, for example. Luckily, in SQL, we can do that quite simply. In SQL, it supports ordering by any column, either a row column that exists in the table, or a column that is a result of equation or a formula or a transformation that we did, as simple as full name or net salary. To do so, what we can do is, after from statement, we can add the new statement, which is order by.
And make sure that order and by are separated from each other. It's not one word, it's two words. So this way we can tell SQL that what we want is we want this query to order the records based on a column or several ones. Let's see how. For example, let's sort our report by full name in alphabetic order. So what we can say is order by full name. Here we don't need to use the double quotes. It's okay. The same as here, by the way. What we can do is, in case your alias is one word, it's okay to not use the double quotes. But if your report or your query will have two or more words in the alias, you need to use the double quotes in this case. Anyway, so here I said order by full name. If I run this and check the full name, you will see that it's all now sorted in alphabetical order, starting with A, going to B, going down to Z. So this is sorting as simple as that. We can sort by both strings, dates, or numbers. So if I want to add the numbers, which is for example the net salary, I want to sort by the net salary. So I can come here and say net salary. If I run this again, I'll see that the net salary has been sorted. And as you can see here, we have this web developer intern who's getting the lowest salary between the employees since he's an intern. And going up, we can check that the salary is increasing in this column. Going down, and you can see the highest salary in this company. But well, this is exhausting to go all the 400, about approximately 400 columns or records to see who has the highest salary, if you're so curious. So what we can do is we can either sort ascendingly or descendingly. Means that we can either sort from the smallest to the biggest or from biggest to smallest, if it's in case for numbers or dates. In case of strings, as you have for the full name, it can be sorted from A to Z or from Z to A. So how can we do that? If you check this slide, you'll see that order by supports two keywords. The first keyword is the ASC, which is the ascending order, which takes the first three characters of ascending word, which is actually the default one. So you really won't use it anyway because it's the default one in SQL. But what we want to do is the descending order, which is the second keyword, DESC, which means the descending order, the first four characters of descending, which will order or sort the query based on the columns that we specified in a descending order, whether it's a number, so it will be from the largest to the smallest, or for a string to be from Z to A. Let's see together. Coming back to the query, you'll see that the net salary is ordered from smallest to biggest here. But I'm so curious to see who has the biggest salary here in our company, and I'm too lazy to go all the way down. So what we can do here is I can come and say order by net salary, and I will add DESC, which means that order net salary in a descending order from the largest to the smallest. Let's run this, and we can see now who has the biggest salary. So he's the head of data, which means like, okay, they're paying much for data these days. So this is the hugest salary or the biggest salary we have in the company. And you go down and you see the net salary is going lower and lower because we ordered the report based on the net salary in a descending order. So what about if we want to sort it by full name, but in a descending order? If I run this, we will see that it's now sorted from Z to A. And as you can see, the full name, the first one is Zona, which is the letter Z, then Yvonne, and going down from Y, W, V, etc. So this is how can you sort your records or your data for a query. In this video, we're going to talk more about order by. So we saw before that we can order our data in ascending or descending order based on any column that we want, either from the table or from the select statement. So here I'm coming again, and what we want is we want to see all the details of our employees in the customer service department or customer care department. So if you can remember from the previous videos, if you still remember, so what we can do is we want to filter by job title. So what we can say is job title, and I want to say that give me all the employees who are working in the customer department. So we can use ILike, since if you can remember, ILike is for case insensitive cases. So instead of taking care that customer is a capital letter or smaller letter, we can use ILike so we can avoid this problem. Next, we're gonna use single quotes for strings, and I'm gonna use the percentage sign. Just remember that the percentage sign for strings, it's about giving a character or more if you're looking for characters, while in math the percentage sign is for the modulo operation, just to make sure that you differentiate between the two cases. Anyway, so look for everything with the port customer. If I run this, you'll see that it gives me all the employees working in the customer care or customer service. Okay, so what we want is next I want to order this data. So I want to order it on several attributes. So the first thing, I want to order them by job title, and next I want to order them by name. So in this case, I can order first the job titles instead of having a random or a messy report. So I can order them so it can look more better. So in case it will be easier for the one who's using the report to see that all those from the same team or the same department for the customer division, let's say. So always remember that the order by comes last in the select query. So when you write the select statement, first comes the select, you select your columns, then the table name in the from, then the filtering using the where clause, and finally comes the order. So I say order by, and then I will say and to order it by job title. If I run this, now it will be ordered by the job title. At first by the customer care manager. Going down, you'll see we have the customer care operator, which is because M is before O, so manager is before operator. Going down, and you will see that it's ordered by alphabetical order. And sure, if I use the descending order, which is this one, it will be the opposite. Checking out, and you see that customer service, which is S. Then if you go down more, you will see that it will be the customer relationship, which is R. So the alphabetical order is from Z to A. Anyway, so first I want to sort it by job title. Next, if you see the report more, you see that, okay, we sorted everything by job title, but you see the full name is a bit, it's a bit messy. So what we can do is we can order by full name next. So in case we have two records with the same job title, we will order the one with the full name in an ascending order. So I can add here, using the comma, I can add full name. And if I put ASC, or I didn't put it, as we mentioned in the last video, the ascending order is the default one. But I will keep it to show you that it will work either way. So now in this query, I'm ordering first by job title, then by the full name. And as you can see, we have first the customer care manager, then the operator. Okay, so when we have two records with the same job title, you'll see that the full name will be ordered first. So first it will be Ahmad, then Eliza, then Lily, then Mitsu. So as you can see, you have the letter A, AL, then Lily with L, and Mitsu with M. So it will sort first by job title, next by full name. What we can do also is, to make it better, is that maybe instead of full name, we can order by the net salary in a descending order. So what we'll have here is the job title will be ordered first, then the net salary. I have a problem here, which is, okay, net salary doesn't exist because, as you can see here, I had a problem which, because of the net salary. If you see my query, the net salary here doesn't exist. So it simply didn't know what is the net salary. So I'll fix my query by adding net salary here, so it will work again. The cool thing about order is that it uses the alias. What we can see next is, unfortunately, where clause can't use the order or the alias. Sorry, I'll show you an example about this later on. So anyway, so here I have the net salary, and if I come here, you'll see that now we ordered by job title first, then by the net salary. So you'll see that for the records with the same job title, we're having the net salary which is the highest first. So for the customer care manager, we have the highest, then to the lowest. Then if the operator will be having the highest and the lowest, and the same thing over and over. Sure, the data is quite random and it doesn't represent any real data, so you can get some wacky salaries, like an operator getting very high salaries for even American standards. Anyway, so this is how you can order, even ascendingly or descendingly. So just, you can specify descending, so it will order this column in the descending order. And if you don't specify anything, or you can just mention ASC, or means the ascending order, it will order it in an ascending order, which is, yeah, this keyword is quite useless and nobody uses it because it's the default one. But yeah, it's there, so you need to know if you need it, or even if you read it one day in some query. Maybe some people like to add it because it will show that, okay, I'm adding this in an ascending order while the next column in descending order. And sure, you can order as many columns as you want. For example, what I can show is, I'm gonna add hiring dates here to show you that we can order by dates as well and timestamps. So what we can do is, I will add here the hire dates. So what happens is, from this now, it will order first by the job title, and in case you have the same job title between two records, it will be the hire date. And as you can see, the hire date is working, so first is 2002, then 2005, then 2006. If you can check the operator, it starts with 97, then 98, etc. And in case you have, let's see that, show you that it can order by several columns, I will use the base salary to make it easier for us, because since it's very hard to find two employees with the same net salary. So if I go here and I will check out, I want two employees with the same base salary. So later on you can check that in case if you have, if you have two employees with the same hire dates, in this case if they're being hired together, so it will for next order by the base salary in this case. So
And I'm gonna show the base salary here just for see if we have anyone with the same base salary. Okay, so if you check it out, now what I'm doing here is, if you check the order by, so it's first by job title, the base salary, and the hire date. What does it mean is, in case if I ordered by job title and they are the same, it will order next by the base salary. And in case we have two employees with the same base salary, so it will order next by the hire date. So let's check together if we can find someone. Okay, so it's very difficult even to find the same base salary here. Oh, here we go. So we can check this one. So we have Letty and Alicia. So for Letty and Alicia, they're working together in the customer care operator team. And what they have is the same base salary, which is 4,200. But what happens is, for Rashida as well. So we have three people with the same job title, which is the customer care operator, and the same base salary, which is 4,200. So as you can see here, we have two columns with the same values. So as we ordered here, we have the job title, we have the base salary, and next one is the hire date. So we'll check out that in case the job title and the base salary has been the same values, equal to each other, the third one will be the hire date, which we can check here between them, or those three. And as you can see, first it was Rashida, which was hired in 2003. Next it was Letty in 2005, and Alicia with 2011. So here's a good example that you can order by several metrics or several columns. So in case the first column was equal to each other, it will order by the second. If the second was equal, it will be ordered by the third, either ascending or descending, depending what did you mention here, etc. So this is how the ordering works. As simple as that. It's quite cool and it's quite easy. And yeah, it's like very simple, but at the same time, it will give you a very good report and a very tidy report based on what you need. When we run a query like this, which is select star from employees, this query will give us all the records in this table. Now it depends on the IDE or the tool that you're using to connect to your database, whether it's Toad, it's SQLlite, it's MySQL server, everything that can depends on which IDE you're doing. It can limit your number of records you bring in there, because now our data is only like less than 400 records here, but what if you have a table with millions and millions of records? You can imagine that this will consume much RAM even in your machine, and it will crash because it will be much memory allocated to show you all those records. It happens often that, especially now we are in the big data era, which millions of records is now quite the norm when you work on any medium to large project. So what you need to make sure is you don't need to consume much of your data and make your relational database quite, exhausted by bringing you all the data that you need, especially if you have a query that is quite complex, much mathematical calculations, for example, and many columns. This all it has an effect on how much time does your query take. Here our data is quite small, so it's quite fast. It's taking milliseconds, but when you have millions of records, this may take minutes, even sometimes hours if your query is very bad. So what you need to do is there is a way to limit the number of records that you're bringing from the database. This can be very, very cool and very easy. It makes your database administrator quite happy that instead of reaching 100,000 records and consuming the relational database's resources, banning anyone else from using it,
you can simply get the first 1,000 or the first 100 records, and even the first 10 records in case you want to check the data of any table you don't have an idea about in the first place. So this one is quite simple. So how should it be working is, you can simply, when you write your query, at the end of the query, you can limit the number of records to be obtained from your database or from your table. So here I'm gonna, for example, limit it by 10. So here you can give the keyword limit, and you can give a number which indicates how many records should be obtained based on the query. So if I run this, you'll see that I only brought 10 rows or 10 records from the table employees in this case, which can be faster. If you can check that 10 records took much faster than, let's say, the whole table. And we're talking about a table of 400 records here. So you can imagine if you have a table with 1,000,000 records, how much time will it take and how much resources you will consume. So always keep in mind to use limit when you use tables with such big data, let's say. For the limit, it should always be at the end of your statement. So for example, if I have where, and let's say, for example, the base salary is bigger than 3,000, and okay, order by, let's say, the first name. So the limit should be at the end, after order, as you can see. So if I run this, here you go. So it brings me all the employees who are the base salary is over 3,000, and it ordered by first name, as you can see here, and it's only the first 10 records. So this can be very, very useful. For example, okay, I want the top 10 employees with the highest salary. We can do that. Sure, there are other metrics to do this, but this is the easiest way to do so. And I see many analysts, data analysts, and even developers do that. Instead of going to the more complicated. It's not very complicated, but yeah, it's the easiest one to get when you want to get a query the fastest possible. So let's see. Okay, I want the top 10 employees in my company. So what I can say is order by the base salary or the net salary, let's say. To make it easier, it's the base salary for now. We won't go into the whole equation thing. And order in a descending order, so it will bring from the top to the down, and limit by 10. And to make it easier, I just bring the first name, last name, and we will see the base. I want to see the title, so let's see the title. We can't see the states, and finally the base salary, which is we need to know how much. So I will run this, and we'll see that it gives me the base salaries, the top 10 in my company. So we'll see the base salary. The top base salary is $9,500, which is for a CIO. They're paying much for information technology from Oregon. And we'll see the next one will be 8,500. It's the revenue accounting and controls chef. I don't know what is that, but it seems like a big thing. So yeah, like as you can see, the heads of departments and the chief officers, the C-level, are having the highest salaries, which is understandable. So this is how limit can work. It can be by everything. Top 3. There we go. So for example, I want the top 3 from a certain state, where state is equal to New York. So here's something wrong, which is where. And as you can see, this is a good example to show you that if you mix between the order, the order of your query, that order by is before where, it won't work. SQL is not flexible with that, actually. So first it should be the where, then the order, then the limit. From this again, I will see the top 3 in New York,
the top base salaries. And as you can see, all three are from New York. This is the job title for each one and the base salary. I'll show you that limit can be anywhere. So if I put it like, for example, before where or before order, yeah, as you can see, it will return a problem or an error. So always remember now, since what we took is select from where, order, and limit for now. So we have those 5 statements. It should be by this order. If we want to browse all the states that are stored in our table called employees, so we can simply do this. We can say select state from employees. And when I run this, I will check it out and I can find all the states that in this column. The thing is, if you look it out, that we have repetitive values, because it simply shows us all the state values for all the 393 records in our table. So it might be a bit annoying. What about if we can filter the values so we can get the unique ones? Luckily in SQL we can do that using the keyword distinct. The keyword distinct helps us filter any column or a group of values, let's say, to the unique ones. If I come here and I use the word distinct before the column that I want to filter and get the unique values from, this query now will show me only the unique values of the column state in the table employees. If I run it now and we will check it out, you'll see now that we have only 45 rows comparing to the 393 rows that we have earlier. And if you check the values now, you'll see that we won't have 2 records, let's say, or 2 values of the same state. So what we can know here is that our employees are scattered around 45 states. So in this case, distinct is very useful to filter any column that we want to only show the unique values. For example, we can show also for, let's say, zip code. And it shows me all the zip codes stored in employees, but the unique ones. And as you can see, we have 362, which is about the same since we have 393, but it's okay. Shows us the unique zip code values that we are storing in employees table. So this is distinct. We're going to talk about null values. What is a null value anyway? A null value is simply a field that has no value. We call it a null value. For example, in some cases, maybe when we set and insert the employee's details into our database, some of those fields are missing, like for example the phone number. So in this case, we can set this field as empty or as null, let's say, to be updated later on. So this can be useful so we can check what values are missing so the HR department can follow up with the employees and they can fill it up later. We can see an example here and we're gonna check our data for the employees table. So what I know that in our data, some phone numbers are missing for some employees. So what I'm gonna do is I'm gonna say where the phone, and here if I want to filter by the null values, I can say equals null. This one doesn't work. It depends on what database you're using. In this case, it will just return no values, which is wrong in our case. In Oracle, it will return an error value, an error that says that you can use the equal sign with null. So what you need to do is always when you use null, you say is null. And always remember this.
So when you use null in the where clause, you use phone or the column is null or is not null. So if I run this, you will see that here we have the phone numbers as null. And again, null is not a value, it's not a string, it's just a no value, a nil. So here, only the UI will show you that we have a value which is null here. So it can help you detect that those columns, those records, it has a null value in the column phone. Sometimes it depends on each IDE you're using or UI. It may be like be a blank, a gray square, a yellow square. It depends what UI are you using. In SQL Electron, it shows you as a gray box with a null value inside it. So anyway, it will help us say that, okay, we have those 4 records and 4 employees with no phone numbers, so we can fix that. And to show you that the phone or the string, the null value is different from an empty string, which many people may fall to this trap, I will show you if we say where phone is equal to an empty string. So I just open and close single quotes, which means that I'm looking for an empty string. If I run this, you'll see that I have 3 employees with empty strings. This might happen sometimes, depends on how the developer is programmed the platform, so it can store empty values, let's say. Maybe it's like, yeah, something related to development side. It's not related to the end users. Sometimes end users put spaces, for example. It may happen. So there are measures that should be taken when storing data into our databases. So we need to keep it as clean as possible. So anyway, this one can be confusing. This case can happen a lot. So don't think that you won't see it anywhere. Sadly, it's like a frequent use case. So what I want to do here is I want to see all the records with missing phone numbers. So I will say it's either the phone is equal to an empty string, which is a single quote with no values, or the phone is null. So you'll see that actually I have 7 records with no phone number. So in this case, what we can do is we can report the HR department to check with those employees to provide them with the phone number, so we can later on update their records in our database in this case. So what we can do is we can select the ID, the first name and last name for those employees, in addition to, let's say, the job title. So in this case, okay, we can report this to our HR department so they can check the phone numbers and get the phone numbers to be updated later. Okay, finally we're gonna start a new section, which is functions. So what is a function? Actually, functions give us much capabilities in SQL since we can do things that we can't do before. For example, if you want the sum amount of the net salaries for all the employees, or we can get the count of employees for certain states, or we want to know the maximum or minimum base salaries per state, for example, or per zip code for other statistics. What we can do also is we can trim or clean up our data. Like, for example, if we have names with no caps, we can fix that. We can trim any spaces if it's before or after the addresses, let's say, or job titles. Such things we can do in normal SQL or what we did so far, so functions can help us do so. There are many functions, they're predefined in SQL and they're gonna help us. So what is a function anyway? A function, we can say it's like a black box that there are a set of instructions inside. So when we give it an input, which can be 1 argument or more, it will give us exactly 1 output. So we can check for examples. This may be scary that for people who don't like maths, but it's quite simple.
So for example, in the first box, we have a function which takes x as an argument and returns x times 2. So if we give it x equals 3, so the output will be 6. For the second function below, we can see it takes two arguments, x and y. So what it returns is x times y. So if we send x as 4 and y as 3, the output will be 12. So what the type of functions that we have in SQL? We have two types of functions in SQL. We have single row functions and multiple row functions. As an example for single row functions, they are the functions that they are executed per row or per record. For example, if we have two records on the left, which are for Sam and David, if you apply the function called upper, what it does is it makes all the characters in caps. So as you can see from the left to right, you'll see that the names Sam and David are now all caps. This is a sample of a single row function. What about a multiple row function? A multiple row function is that it takes all the records field as an input, and as an output it will give us exactly one value, which depends on what function did we use. For example, there's a multiple row function called sum, which gives us the sum amounts or the sum of all the values for a certain field. Let's say we have the field called amount here, which has those values as we see 500, 300, 200, and 700. If we apply sum on the field amounts, we will see that it will return the value 700. So this is the difference between single row and multiple row functions. In the next video, we're gonna start with multiple row functions because they're quite more useful, let's say, or yeah, it's very useful to know them first since you can do many stuff with those. And we will go eventually with single row functions and learn what functions and what type of functions do we have in SQL. In the last video, we talked about what is a function and what type of functions do we have in SQL, which are two types, multiple row functions and single row functions. We're going to start with multiple row functions in SQL, and we're going to play with 5 functions which are the main multiple row functions in SQL. They are sum, the average, count, min, and max. Please note that those are the most important functions for multiple row functions. And the first 3, you're gonna use them a lot. So make sure you can understand how do they work. They're quite simple and quite easy and quite fun. Getting back to SQL Electron, what we're going to do is we're gonna apply the multiple row functions we saw in the last slide into our table employees. And we're gonna start with the function sum. What sum does is it gets us all the total value for a certain field. And sum only takes numeric fields, means that only fields with numbers. So since it does the addition on all the records for this field. So since for our table we have base salary as a numeric value here, so we're gonna say that what we want is we want the total base salary for all the employees in this table. How can we use the sum function? What we come here is we come to the select statement and we say sum, we define what function do we need to use, and then we need to pass the arguments of this function so it can give us the output, which is the total amount or the total base salary in this case. So we will open parentheses, and inside the parentheses we need to say what argument or what arguments, depends on the function and how many arguments does it take, we need to pass or we need to calculate. So sum takes only one argument, which is the field that it will give us the total value of, or the total value of all the records. So we're gonna pass the base salary,
which is the field that we're interested to see the total amount of. So this is it. What we did is we defined what function to use, we open parentheses, and we passed the arguments or the arguments that this function needs to return the output that we're looking for. So this function or this query will return the total base salary for all employees. Let's run this and we'll see what it gives us. As you can see here, this is the total amount of all the base salaries for the employees in this table, which is $1,362,800. So this is sum, as simple as that. Let's make it more fun, and let's say that, okay, I want the sum total, the base salary for a certain, let's say, state. So I can say where state is equal to Washington. If I run this, you will see that the total base salary for the employees stated in Washington is $22,500. We can use New York, for example, or California, since I think we have many employees from there, and you can see it's more than what we have in Washington, which is 189,000. So here's how the sum function works. Now to the next function, which is called the average. What average does is it gives us the average numeric value for certain values in a certain field. For example, we want to see the average base salary for all employees in our table. So what we can do is the same way we did with sum. We say select, and then we call the function average, which is named AVG in SQL as an abbreviation or short for average. So next, we open parentheses so we can send the argument that, or the field that we need its average, which is in our case the base salary. From which table? From employees. As simple as that. We run this. So we run the query and we see that it returns the average of all the base salaries that we have for all the employees in the company, which is by average $3,400 or about $3,500. And you can see it's a real number or a float number, since it should return the real average and not only an approximation, since this function is used a lot for calculation and for averages if we want to calculate the mean or the median in later functions. So here it's quite simple. As you can see, the same way we used with sum, we use with average. And what we can do also is we can filter by states, and we can say we want everything from New Jersey, for example. We want to see the basic salary of the average base salary in New Jersey. And here you go, you can see that it's the average salary is a bit higher than the average salary for all the company. As you can see, this can be very useful for comparison if you want to look for the average salaries and the median ones among the states. We'll see later how can we see for all the states and not only for a certain state using the group by. So we're gonna focus now on checking all the functions first, and the cool part is I can use both average and sum at the same time, so we can do something like that. So here what I'm doing now is I'll be having two columns, one for the average and the second one is for the sum. So we will see both values at the same time, so I don't need to run two queries in this case. So as you can see here, I got the sum base salary for New Jersey, which is 145,200, and I have the average as well. And the cool part, I can, for example, I can get in, like, okay, I want everything that is in, let's say, Florida, and we can say Colorado. And we run this, and we can have the sum for both states, and we can check it out, the average, how it is. What we can do also is you can fix the alias for those, like, instead of having this auto-generated alias, we can do as, and we can call it, you can use this or no, average base salary, or base sal. And here you can say as sum base salary. If I run this, you see that we could fix the alias for the result of our query, select query here. So yeah, it's nice. Now we're gonna talk about the count function. What the count function does is it counts the occurrences of values in a certain field. So this one can be quite simple and quite straightforward. What I'm gonna do here is I'm gonna use the count, and let's see that, okay, we want to count how many values in a certain field or a certain column. Let's say, for example, count first name. So what we're gonna do here is we're gonna count how many first names do we have in Colorado and Florida, which means that we're counting how many employees actually do we have in those states. If I run this, you will see that we have 31 employees in the states of Colorado and Florida. If I remove this and we'll check it out, how many do we have 393. And you can check it out that it's true if you go and simply say select star from employees. You will see that we have 393. So the count is very useful if you want to count how many fields or how many records we have, for example. So for a certain table, any table like orders, students, books, so you can simply count how many books do we have, how many employees, how many students, how many cars. So yeah, the count is like to count the occurrences of how many items do we have in a certain field. You can count the whole table, which, okay, for our example, the same way we counted for first name, you can simply make it more general by saying select count and then use star. So in this case, what you can do is you can count how many records are in a certain table. So this one is quite used a lot because simply people want to know how many records we have in a certain table. So even if you have a huge table and you want to know how many records we have, you use count star, and you'll see it will return us the total number of records. And maybe someone will say that, okay, I can't depend on this. Actually, this one is supported by the UI or the IDE, SQLlite. But the thing is, you may not see this when you use the command line, the terminal, or any other UI, because sometimes it can be too expensive if the table is huge. So let's take another example. What you can do is you need to remember that for count, it doesn't count the null values. If you can remember from the last video, we talked about null values. So when we have a null value, you can't use count, or let's say count won't count it, to say the least. If you can remember, let's see, we have select phone where phone is null. So we checked together and we found we have 4 records with the phone number as null. So if I come here and I say count phone, as you can see, it will return 0. Although, like we saw earlier, that we had 4 fields or 4 records, right? The thing is, count doesn't count the null values. Remember this. So the same, for example, if you can say, and I'll show you that if I say the select counts for phone in the whole table, you'll see that it's missing. We saw that we have 393, and what I can show you is I can do this count star. So we can compare between the total values. Oh, okay, sorry. Here in SQLlite, in case you're using more than count, you need to use an alias. It's a weakness, or it's a bug in SQLlite, or let's say a limitation. Anyway, so count all, and I'm gonna call this count as count phone. So here, the count phone, we have 389 phones, but the total employees are 393, which means that we have 4 phones with the values of null. And you make sure that there's a difference, since it could count the empty ones, which means if I say select phone, where phone is an empty string, you'll see that we have three records with empty phone, which is like can be a space, or here in our case just empty. And we mentioned before that it can be due to development, or any case that it entered an empty string, which is different than null. Anyway, this is count, and this is how it works. So what you can do is a count. Here, if you return back and we want to see the total, so we can say now we need the count star, or which counts all the employees. We have the sum for the base salary, and what we have is also the average for the base salary. So here, so far we took 3 functions, and we can see that we have 393 employees with a sum base salary of 1,362,000 and an average of 33,467 or $68 approximately. So we see 3 functions so far. Those 3 are the most important. Keep them in mind. The other 2 are less used. They're important as well, which are min and max, but keep in mind that those functions are quite useful. So keep them in your mind, and they can be very useful in your career or in your studies.
Let's answer this question. How many employees do we have per state? So let's see, how can we do this in SQL? If only we had a function that can count how many employees do we have, which we do, which is the function count. Let's see how can we do that. Getting back to SQLlite, let's see how can we count how many employees do we have per state. We saw earlier that what we can do is we can count how many employees in the whole table, and it's 393. But what they want is how many employees do we have in each state. They want to know how many do we have in New York, New Jersey, California, Colorado, Florida, etc. So what will you do in this case? You think it's a good idea to do this every time? Sure, you can do that, but since we have about 45 states stored in employees table, that will take like 45 queries, and that will take you at least 45 minutes to do that, while you can do that in 1 minute. Let's see how. What we can do is, since we want the state here, so we need to show the state. And then what we can do is we can use count and star. So do you think that using count state will work? What we want is we want to count how many employees, means how many records do we have per state. So here what we're doing is we're gonna count how many employees do we have per state, and from our table, which is employees, and this will give an error. The error says that the column state, which is in employees table, must appear in a group by clause. What does this mean anyway? When we mentioned that we want to see
the how many employees do we have, or the count of employees that we have in the table per state, we need to say to SQL that the counting is based on states, which we can say it's the dimension of the query. What do we mean by dimension is that, okay, the metrics that we want to take here, which is the count, on what dimension that we want this count to be based on. When we have no dimension, usually it's the total number of records. But here what we want is, we want to say that give me the count of records per state. So to mention that, for SQL to know that it should be per state, we need to define that in a new clause called group by. So here, what I need to do is I'm going to remove the semicolon, and after from employees, I'm going to say group by. Here I can define what dimensions that I want to apply the count on. Here, for example, we want the state. So group by state. So in this case, the SQL query will count how many employees or how many records do we have in the table employees per state. Let's run this and see what happens. And here's the magic. You see here that the SQL query counted how many records, which represents the employees we have in the table, per state. And if you check here, you'll see that for California we have 55 employees, which I think they are the most that we have. You can check later if you want. And you can check for Texas, for example, we have 26. For Ohio, we have 17. For New York, we have 34, and etc. So this is the magic of grouping and using group by with the multiple row functions, that we can do calculations or analysis in a very easy way. And here what we could do is we know how many employees do we have per state. Sure, you don't need to put state here, but as you can see, yep, we can see what state is this. Like the data is, we can't understand it. It's useless because I don't know for each count, like 55, for which state does it belong to. So it's not about what do you put in the select statement, but what do you put in the group by clause. So since we defined that the group by clause will be based on state, it will do the grouping for us and count for us based on the states. But sure, for us, we need to see it in the end. So what we need to do is we need to say states and along with the multiple row function that we're using here, which is the count. So run it again, and we can see per state how many employees do we have. Change of plans. Since now they saw how can we easily do finding the count of employees per state, now what they want is we want to know how many employees do we have per state and job title. Means that, okay, we want to count how many employees do we have in per state, and depends on the job title, we need to count how many employees we have holding the same job title on each state. For example, how many customer care representative do we have in California? Or how many software engineers do we have in Washington? Getting back to our query from the last video, here we will see how can we add the job title as another dimension in our query in order to see the count of employees per state and job title as mentioned in the last slide. So here we can simply add the column job title to the group by and sure to the select statement so we can see it as well. And let's see, here we can see that now we can see how many employees do we have per state per job title, and it might be mostly 1 or 2, so we can look it up here. which can be a bit difficult. So let's do some sorting and ordering, so our script can be easier to read, or our results can be easier to read. Let's say, for example, I want to see what are the most job titles being hired in our company. So what we can do is, first, what I'm doing here is I'm gonna give it an alias name for the count star, since it will be easier this way. And then what I want to do is I want to order the data descendingly by the count all. So here what I can do is order by, and I'm using count all, and in order to sort the data in a descending order, if you can remember, we use DESC, which is for descending. And let's see. As you can see here, the most hired job title in the company is an accountant based in California. And we saw that by the first record that we have here. If you can do something like that, limit 1. And we can see only one record in this case, which can be more clear. So running this back, and we can see how many employees do we have per job title, per state. If you want to make it cleaner, we can order not only by count all, but what we can do is we can order by job title and then by state. So first what is gonna happen is it will order by the counts in a descending order, and if two records have the same count, it will order by job title, and if it happens that they have the same job title, it will be the state. If I run this again, we will see that now we can see a little better and cleaner data. Ordered first by counting in a descending order, then job title in alphabet order, and the state in alphabet order as well. But sure, as you can see, since the counting is first, so you can, the state alone can, it appears like it's random, but actually it's ordered. So you can see, like, for example, if you can go down, you'll see here that when we have software engineers from different states, this one is from California and this one is from Florida. So the one from California came first, since the state is applied for a sorting. So California came before Florida. Yep, this one is like we already talked about in order by video, but yeah, I'd like to remind you about it and how can we use order for such queries. So that's it for counts, and like, yeah, we can see how can we use sum, min, max, average on grouping as well.
Now let's talk about single row functions in SQL. Opposed to multiple row functions or aggregate functions, single row functions apply changes on each value in the field. Let's say we have those two rows or two values, Sam and David, from the left, and we apply the single row function upper, which it converts each character to uppercase. So after applying the function upper on those two values, you'll see on the right that all the characters are in upper caps. So we will start talking about character functions in SQL. So for characters, we have two types: case manipulation functions and character manipulation functions. So for case manipulation functions, it takes care of the case of each character, if it's upper or lower. And for character manipulation, they take care of cutting, splitting, counting, or doing padding for the characters. So some more operations on characters, on the words, or let's say the strings. We're going to start with the case manipulation functions and show you examples of how does it work. Getting back to SQL Electron, I'm going to show you how can I use case manipulation functions, such as upper, lower, and init cap. So to use single row functions in general, we need for sure select statements. So what I'm gonna do is I'm gonna say select, and then here what we can do is we can either try on dummy values, or later we can try on our table, which is called employees. So I'm gonna start first with using dummy values. So I'm gonna show you both ways. It can be useful if you want to try any function by yourself and you don't want to manipulate with the data that you have already. So let's say we have hello world, and I'm gonna type it this way. So if I run this, you'll see that this is okay, dummy select query that shows hello world, and that's it. So I'm gonna work on hello world string, and I'm gonna show you how can we apply the case manipulation functions on this character. So I'm gonna say upper, and if you can remember from the multiple row functions or aggregate functions we talked in the last videos, we can use any function by calling the name of the function and opening parentheses and passing the arguments of this function. Some functions have one argument and some have even more in single row functions. So for now we are using simple functions. So this function upper takes only one argument, which is the string, which will modify or manipulate the character case. So here we have now upper for hello world, and if I run this, let's see the results. You'll see that all the characters in my string became upper caps. So this is what upper function does, as simple as that. So what about lower function? I will copy this, and so I'll keep it here. If I want to check the function lower, what it does is it converts, as opposed to upper, it converts all the characters to lower caps. If I select this and run it, you'll see that hello world has all the characters in lower caps, including the H and the D, as opposed to the upper function, which converts all the characters to upper caps. Finally, let's talk about init cap. Init cap, maybe it's the most useful one in my opinion, because what it does is init cap, it converts the characters, the first character of each word in your string to upper cap, and keeps the rest of characters in each word as small caps. And as you know, like usually when we define names or addresses, or names or addresses in general, or even titles, we prefer writing the first character should be in upper cap, while the rest of the characters should be in small caps. So in case you have strings, or long title or string that is not written correctly, or in a way that it can be shown, like for example for a website, or we can show it for a report, that all caps can be either upper caps or small caps, init cap in this case will fix it for you. So you don't need, like, imagine having like a million records and you need to fix those. Sure, you can fix them later in seconds or even less, but yeah, for now, if you have this and you don't have the chance to change the data in your table, so what you can do is using init cap. So if I run init cap now, I will show you how it works. See here that we have hello world. Maybe you didn't notice the change, but what happens is word used to be a small cap for W and an upper cap for D. What init cap function does is fix it for me, and the W now is an upper cap, while the rest of the characters, including D, is small caps. So to show you more that how it works, if I make H small cap and run it again, as you can see, it fixed it for me. So this function can be really useful if you want to fix your strings in your addresses, in your names, or in your titles.
If we go to, for example, our table, and I'm gonna limit it for 5 because we don't need much data, you'll see that actually the data is quite neat, mostly. So first name, last name, and addresses are all good. So maybe we don't have much, even the job titles are all good in my opinion. But anyway, I can show you some examples. So for example, if I want to do this, upper for first name, lower for last name, and sure, I can use as many functions as I want in each column, and it doesn't affect at all. So if I run this, you'll see here that now the first name, which is on the left, is all in upper caps, while the right column or field, which is the last name, is all in small caps. So this is actually how it works, as simple as that. Can be useful sometimes. Well, maybe you won't use them at all, but they are there if you need them anytime. In the last video, we talked about case manipulation functions, lower, upper, and init cap. If you didn't find those functions any fun, then absolutely you'll find character manipulation functions more exciting to work with. We're gonna start with concat and length functions. Let's see what do they do. Getting back to Collectron, we're gonna see how concat and length functions work the same way we did in the last video. So for concat, maybe you have an idea what does it do, and we did it before. If you can remember, we have the double pipe operator, which concatenates or joins two strings together. So if you run this, hello world will be concatenated or joined in one string. Concat does the same. In case if you don't like this operator and you find it not cool, so what you can do is instead you can use the function concat. It's short for concatenation. So for concat, what it does do is it takes one to many arguments and concat of strings and concatenate or join those strings all together into one. So here if I do the same and send hello world as two arguments to concat, it will return the same result as the pipe operator, double pipe operator does. And sure, what can I do is I can fix this by sending a third operator in between, or third argument in between, which is a space. So I can fix the hello world to be not stick together. And sure, I can send as many arguments as I want, and it keeps working. So concat is maybe the first function we saw that it takes more than one or two arguments. It takes actually as many as you want, which is quite flexible. So this is for concat, but what about length? Length is very cool and sometimes useful, which counts the number of characters in your string. So don't mistake in length to count. A function is multiple row. It counts how many rows do you have or how many values in a certain field. Whether length is the length of your string. It counts how many characters in the string, so it's called the length of your string. So if I say length, and I'm gonna say hello world in this way, it takes one single argument, which is the string, and if I run this, you'll see that it will return 11, has how many characters in the string hello world. And sure, some people may get mistaken and say that, oh, there is only 10 characters, hello is 5, and world is 5, so it should be 10. Remember that there is a space, which is a character as well, and it's counted. It doesn't count how many characters or how many alphabets, but also how many characters in general. So if I add exclamation marks and question marks and even tabs, it will count that. Sorry, let me fix it again. So as you can see, it counts every character that you have in your keyboard,
which is quite useful if you want to count addresses, or you can check the length of the longest address so you can fix your tables later on. So this is how concat, and length functions work. Concat concatenates or joins strings together, the same as for double pipe operator. And length, it counts how many characters you have in your string that you pass. So let me show you something cool, that for functions, what you can do is you can pass a function output as an argument for another function. Let me show you something. If I go here and copy this again, what can I do is, you know that this query will return hello world as a string, correct? So what I want to do is I want to count how many characters hello world that is returned by this query, how many characters does it have? Can we do that? Sure. What I can do is, there's a simple trick. What I can do is, instead of sending the static string, I can instead send the output of concat function. So what happens here is, when you have such query, first the concat function will run first. So concat will take those arguments and return hello space word and 2 exclamation marks, and pass it to the second function, which is length. So length will take this as an argument and it will return the result, which is the length or count characters of this string. Let me show you. There you go. So it returned 13, which is the total number of characters concat function returned. And you can see that hello, 5, word 5, 1, and 2. So a total of 13 characters has been counted from the output of concat function. So this one can be really useful in some cases. Let's see some example now. We can see here that returning back to our table, select star from employees. Let's limit them for now by 10. What we can do, for example, is we can concatenate our first and last name and then count how many characters do we have in those names. So what we can do is, I'm gonna first concatenate the first name and the last name. And if I run this, you'll see that now we have the first name, last name, and which was called, if you can remember, the full name. And sure, if I run this again, you'll see that, oh, okay, they're stick together. How can we fix this? Sure, you should know already that we can add a space and it can be fixed. Cool. Next, what I want to do now is I want to count or know the length of those names for our employees, for just a curiosity. We're too bored to do anything, so let's do this. So what we can do here is, since we have a concat function returns the full name, we can use that in our advantage to count how many characters do we have. So what we can do is we use the length function, which counts how many characters, and we can pass the output of the concat function as an argument. So if I do this, if I run this now, you'll see that we return the length of characters for each row, for each name. Sure, this one is not visible at all. I don't know what names that we change. So what we can do is, I'm gonna copy the concat here and I'm gonna send it. So we can see at least what happens. And exactly here, where it shows that the concat is the full name, Malaios, and yeah, it has 9 characters, which is Ma to Laios, which is 6, and we have the space character, so the total of 9. We have here a very long name, which is 19 characters. I can't even read this. Hop in corner. Okay. So
here what we can do is I can fix it with some alias, so as full name, and here as full name length. If I run this again, so I could fix it here, and I will remove the limit so we can see everything if you like. So here you go. Good. So we fixed the aliases here to full name and full name length. So let's order this by for full name length. So we can see what is the shortest name and the longest name that we have in our table, since we're too bored to do anything. So let's run this. Okay, there's an error, which is say, yeah, exactly. I missed the keyword by here by fault. Coming here again. And yep, it runs. So as you can see, we have the shortest name here is Lin Pa, which is Lin is 4 characters, Pa is 3 characters, and you have the space, so a total of 8 characters. T. Smith, and yeah, next we have 9 characters for Vineshire, and etc. Let's see the longest name. And sure, I'm too lazy to go down about 400 records, so what we can do is our majestic descending order option here. I'll add it here, and let's see. Here we go. We can see that we have the longest name, which is 21 characters, and the name is Christian Eschberger. So yeah, functions can be really fun. You can work around. Try using concatenate or using length on addresses, phones. For example, what you can do is you can stick phones and addresses together.
We're gonna start talking about singular functions for numbers. So we have 3 functions which we will cover in this course. They are mod, round, and trunc. Here we're gonna cover those 3 functions, and we're gonna start with the easiest one, which you know already, which is module or mod. So if you can remember that we have a 5th operator, math operator in SQL, which was the modulo operator, which returns the rest of the division between A and B, or the left side and right side of the equation. So for example, if we say 5 modulo 2, it will return the rest of the division between 5 and 2, which was 1. Another example to remind you, which is, for example, if we do 17 modulo 3, which is the remainder of 2, since when you divide 17 by 3, it will return 5. So 5 times 3 will be 15, so the remainder will be 2 in this case. So the mod or the modulo function is the exact same as the modulo operator we have. So if you say select mod, and then, okay, any numbers with, let's say, 17 and 3, it will return the same result as before. So this is simply the mode function. So yeah, we know already what does it do. So let's move on to the round and trunc functions. As for round functions, what does it do? For round function, from the name, what it does is it does rounding for any number to the nearest decimal number, let's say. So, or it may be to be an integer or floating point. As a simple example, if you have a number, let's say 2.5, if we want to round this number, it should go into 3. Why? Since what we have is when we have a fraction of 5 and above, it will be considered as to be, incremented into the nearest integer number. So it's gonna be 3 in this case. Everything from 2.0 to 2.4, okay, it will, if you round it up, what it will return the number 2. But if you round everything from 2.5 onto 2.9, and sorry, I'm using this, let's say if 2.9, yeah, 2.5 to 2.9, so it will be rounded into 3. Let me show you an example. So if I can say select round, and we can pass 2.5 in this case, it's gonna return 3. Cool. So if I can send, for example,
9, it will return should be the same. Yep, exactly. So what about if I send 2.4? What will it give? Exactly, it will be 2. So always remember that when you have a number from a fraction from 0 to 4, it will be into the lower integer number, which is 2. While when it is the fraction which is between 5 to 9, it will be to the highest increment number or highest integer number above the value that we set. So this is for round in similar. So if we add 2.45 in this case, what will it return? So you'll see that it also returns 2. Even if we have all 9s here, as you can see, it will return 2. So what if we want to round but with fractions? For example, if you have this number, which is 4 and 5 9s here, 5 9s. So if I do that, okay, do a round but with floating points of 2 decimals. So if I run this, you'll see that it gives me 2.50, which is 2.5. Because here what it does is it checks the values for the two fractions, and as you can see here, when you try to round it up, it will become all by zeros, so until it reaches the number 5. So yeah, it will return 2.50. Let me make it simpler. So for example, if I can say 3, 7, 8, for example. So here what it does is, if I want to round it up, it will look at 8 and it sees that, okay, it's between 5 and 9, so it will round it up to the next decimal, which should be 8 here. So it will be 2.38. If I run this, and you will see that exactly it's 2.38. While if this was between 0 and 4, and let's say 1, so if I run this now, you will see that it's 2.37, because this one is between 0 and 4. If I can add as many floating points, so if we say 4 and I'm gonna add 6 and 0, so what do you think the rounding will be? It should be 2.372. Why? Or sorry, 23716, because we need 4 floating points, and checking here the floating points, you'll see that the fifth floating point is 0, so it's gonna be the same. Exactly. So what if we use 8 in this case? Now, since this one is 8, which is between 5 and 9, so it will be fixed to 3717. Good, as we expected. What about if we say 1 in this case? What do you think will be the result? Here, if we can fix it together, so since we have 8 here, so this one will be 7, this one will be 2, and since this one will be keep 7, but this one will be 2.4. If I run this, exactly. So this is how it works. This is some sort of maths, so it depends like how powerful are you in maths, but it's quite simple. It's just like rounding to the next integer or the next fraction. Usually you can use it either with or without a second argument, which proposes how many fractions do you want in your number. The default value, sure, it's 0. So in this case, it will return 2 because it's 2.37. So return 2 since it's between 0 and 4. And what we have also is we have even the second argument as a -1. And this one can be tricky if you can keep up with me. I'll remove those. So what about if we pass a negative number for a round value? I'll remove this and I'm gonna choose let's say 52. Okay, for example, let's make it an integer number. Let's say that you want to know the number in tens, let's say, in decimals that is greater than, you take the unis, then the tens, then the hundreds, exactly. So then -1, when you use it, it will gives you a base. It starts giving you
the decimals from the left side of the fraction. So sure, this number is considered for 52.0. So when you say you want the -1, it's like, okay, moving the fraction, and yeah, you will get the tens in this case. So if I run this, let's try to look it up. As you can see, it will return 50 since it gives you the tens here after rounding up. And as we said before, since the second single number is between 0 and 4, so this is why it was rounded into the lowest 10. So it will the 52 was rounded into 50, while if it was 56, okay, and I will move this for now, and now I do rounding. The 50 was rounded into 60 because 56, since the first digit is between 6 and 9, so it was rounded into the next 10, which was 60. The same what we can do is for -2, if you have a number and let's say 278. So, or let's make it easier, 270. So if I want to round 270 to the next 100, will it be 300 or 200 in this case? Sure, if you look it up, it's nearer to 300 than 200. And sure, it will return 300. But what if I say 0, 1, which this one is quite similar. So yeah, it's nearer to 200. So rounding, what does round function do is you rounded the number up to the next decimal value or to the next floating number that is near based on the second argument. How many digits do you have, or how many places are you sending? As we said, the 0 is default number, so when you round any number, it will be rounded to the next integer. When you send a positive number, it will be rounded by the next fraction or floating points in how many decimals you want in the right of the floating point. While when you send a negative number, in this case, you want by single numbers, tens, hundreds, thousand, etc. So it's about, okay, going left inside of the number or heading right. And always remember that what round does is it checks the value and it sees if it's between 0 and 4, it will round up to the lowest number. While if the fraction is, or the number, or yeah, the decimal that we're checking, its value between 5 and 9, so it will be rounded up into the highest integer that is near to it. So yeah, keep this in mind.
If you take a look at the public schema here on the left, you see that we have two tables, departments and employees. We worked a lot on employees table, but what about departments? Let's take a look and we can run this query. So you'll see that we have a set of departments from administration, marketing, IT, sales, etc. What it means is, for each employee, they should be included in one of those departments. How does this work is, if you take a look at the employees table, you'll see here that if you go to department ID, you'll see every employee has a department ID, which means that every employee is included in one department, and the ID refers to which departments they are in. For example, let's say that we want to look for Carly Bolter. If you're going to check here that her department is number 6. If you want to take a look at the department number 6, we'll see that her ID is equal to 6 here. We can run this and we'll see that she works in the customer service. Let's take another example. You'll see another employee, for example, Roosevelt office. So he's working at the department ID number 1, which means that it's, I guess it's marketing. Oh no, it's administration. So you'll see that each employee is included in one department, which how companies work. So some people may ask that why the department names are included directly into the employees table. The thing is, this is very useful for what they call denormalization. Means that
you don't include all your data into one table, so in case that any changes should happen, for example in the departments. But if we want to change the department name from finance into finance and accounting, this one can be easily done changing the departments table. When you select from departments table joining employees, you don't have to worry about the names anymore. Meanwhile, if it's employees which has the names of the departments, in this case you need to change much more records in this case. Meanwhile, if you want to change one department's name, you only need to change one record from departments in this case. To understand better the relationship between departments and employees, let's see the next video and explain more with more examples.
Let's take a look at this diagram here. You will see that we have departments and employees as separate tables. For departments, we have the ID and the name. Meanwhile, for employees, we have two IDs or two keys, as we will discuss later, which are ID and department ID, as well as the rest of the columns of employees table. Anyway, what we care about here is the IDs actually of both tables. You'll see that for departments and for employees, we have what we call ID or the primary keys, which is referred to PK. What does it mean is, if you take a look at employees or departments, you will see that each record in those tables have a unique ID. In employees, you don't have two employees with the same ID or the same number in the ID column. So what you can differentiate between two employees or more is about their IDs there. The same with departments, that you have each department has a unique ID or what we call a primary key. So in this case, you can define the uniqueness of each row and each record for each table in this case. So in case you want to identify each employee and which department they are included in, the ID of the departments is the one responsible to tell you which department this employee works at. So to link those two tables, what we can do is we can use the department's ID as an identifier to know which department this employee is working at. This may look or sound complicated, but it's quite simple. As simple as we know that for each employee, they should be included into one exact department. So what we want to do is we want to say, so this employee number 309, let's say, for which department they work at. So what we need to do is we need the department ID to be included in the employee's record. So what we can do is, for example, if he's working at the marketing department, which is, let's say, the ID number 5, what we say is the employee number 309 is in the department ID number 5. So the department ID is the one that will refer to the departments table, and the department ID will help us later to fetch the department's name. If I want, for example, to show a full report of all the employees and their departments for my boss, instead of selecting from two tables separately, which are departments and employees, and then manually link or copy and paste the department's name from the employees, what I can do is I can simply link or join those two tables using the department ID as the identifier to get the department's name. We will see that later in the next video. For now, I'm going to discuss later or explain more about how those tables are being linked or working at. You'll see this tiny link or between those department and employees. It means that departments and employees have a one-to-many relationship from left to right. That means each department has one or more employees. Meanwhile, the employee can be in exactly one department. So this diagram showing us the relationship between departments and employees. This diagram is called the ERD. and it means the entity relationship diagram. Why not why didn't they call it table relationship diagram instead? Because entities or they can be tables, they can be views, or they can be other elements that the database supports. But anyway, in most of the cases, you either work with tables or you will work with views, which we will see later in the next section. The thing is, department as an entity and employee table as an entity, showing us the relationship between those two. So if you have a very complicated schema, you will see that if anyone or any engineer wants to take a look at how the schema is being built or your database is being built, by taking a look at the ERD, they will fully understand how does your data being stored in your database and what is the relationship between those tables that you have. This one is quite simple. This is only two entities or two tables and with one link. In some cases, if you take a look at ERD in Google, we'll see much more complicated ones. Let's take a look at more examples. Here in customers and orders, you'll see that customers can have one to many orders. And when you go to the restaurant or you buy something from Walmart, let's say, you can buy several times in several weeks or months. And for each time you buy, you will get an order or a receipt, let's say. So the customer can have one or more orders from the same retail store. Meanwhile, the order has only one customer. Sure, you can find an order which is paid by more than one customer. It doesn't work. Even when you go to a restaurant and each of your friends wants to pay for their bill, you'll have different orders or different receipts. So you see that each customer is linked to order or more. Meanwhile, the order will be only linked to one customer. Same when you do, for example, waiting for a parcel from Amazon. So a customer can have multiple orders, but the same order, it will be only related to one customer. And you'll see that what we can link is the order to be linked to the customer. We used a foreign key, an FK. That's the same one that we used in employees. The employees here, you see that we have a foreign key, which is the department ID. So we can link this employee into the department. Meanwhile here, the order to be linked or related to the customer, we need a foreign key, which shows us the relationship between those two tables or entities. In this case, for customers and orders, it's the customer ID. Means that when you read an order from the table orders, you will know who is the customer ordering this record. Another example, let's say, is instructors and courses. You'll see instructors like me can have one course or can have many courses. In this case, you'll see that the course is linked to one instructor because let's say in general, courses, let's say in university courses, can be only taught by one instructor. It can, in some cases, can be taught more than one, but okay, it can be a different use case. In our use case, we were saying that an instructor can teach one or more courses. Meanwhile, the course can only be taught by one instructor. You will see the foreign key is the instructor ID. So in order to relate or link the course into the instructor, I use a foreign key called the instructor ID. In this case, I can know if I'm reading the course record, for example, from the table, I know who is the instructor that is taking or teaching this course. So to recap, as you see that we have primary keys and foreign keys. The primary key is a unique ID for each record on the table. Meanwhile, for the foreign key, it's the ID that links this table or links this record into data from another table. So departments and employees, each employee will be included in one department. So they have ID and department ID to show which department they work at. For the customers and orders, you'll see that each order has a customer ID. So you know this order, who is the customer who ordered this. And for instructors and courses, you'll see that
For each course, there's an instructor that is teaching this course. What are we going to work on now is we want to join the two tables, employees and departments, together in order to get the department name for each employee and show it in one report. If you get back to SQL Action or any SQL client that you're using, you'll see that we talked about the primary keys and foreign keys. The primary keys are the unique IDs that each record in each table has. Meanwhile, the foreign key is the link between two tables. We saw that for departments and employees, what links those tables together is the department ID in employees. If you take a look at it again here, and you will see that we have the department ID, which shows us which department each employee is working at. So what we want to do is we want to link departments and employees together in one query and show the department name for each employee. How can we do this? You'll see that employees have an ID or have a number, and the departments, they have the IDs and names. What I want to do is replace the department ID with the name instead. If I want to do a report and show the name of all those employees with the department ID, the one who is responsible or the one who is going to read my report and extract data, they don't know which department each employee at. Like the HR, if they're gonna take a look at Audrey Yaw, and you'll see that the department is 5, they don't know that it's marketing, administration, finance, and you won't go and manually fix that, won't you? Yeah, this is what the departments are for in the first case, and computers, so they can do things for us. Let me show you how can we join those two tables together to get the data that we need. So here, what we're going to do is we're going to select. What I want to show is the first name, the last name, and I will keep this for now. So I want to show the department name, let's say. Okay, so the department name is going to be inside departments, right? How can we get that? Simply, for department's name, if we're going to take a look and run this, you'll see that the department's name in this table is called simply name. So what we can do is we will use the column name, which is called name, simply as that. So here I'm using name. Okay, let's see that. You may be confused now. How can we get the column from a different table? How does this work? Sure, if I run this now and I say, okay, just select from employees, and I run this, it will return an error, which is name doesn't exist. And sure, the column name, it's called name, does not exist in employees. Okay, so what I want to do is I want to bring the column which is called name in departments. How can I do that? It's by joining those tables together. Join may sound like a very complicated word for now and term, and you will see that it's very simple for now. So what I want to do is I want to get the data from both two tables. So here in the select statement, we worked all along selecting from one table. What we can do is we can select from different tables. It's not necessary to select from only one table in the same query. So what I can do is I also can select from two tables in the same time. Well, yeah, I know, it's awesome. So here, what I'm doing is I'm selecting from two tables, employees and departments. And here, I do the exact same, which is I select what columns do I want from those tables. And I see that I want the first name, last name from the employees table, while I need the department name from the departments table. Do you think this will work? Sure, what we need to do next is we need to link those tables together, because I will show you later that if you don't mention what is the link between those two tables, you will get very wrong data.
So what we want to do is we need to use the where statement. And here what we need to say is that we want to make sure that that employees and departments are joined correctly. How can we join employees and departments correctly? Let's take a look back, and you'll see that for departments and employees, those two tables, what links them together? What makes the employees record linked to the department's record in the departments table? If you can remember, in the employees, we have the department's ID, which relates to the ID in the department's table. Okay, great. So what I want to do is to say that join those two tables together and join two records together from different tables where there is this condition that the department's ID from my employees table is equal to the ID from the department's table. Okay, is this enough? No, not really, because when SQL will read this, it will understand that this ID and this department ID, you may mean that it's from the employees, which won't work. And it doesn't work except for maybe the employees from ID 1 to 6. You want to mention that this department ID is from employees. Meanwhile, this ID column is from departments. So how can you do this? You can here say get it from employees dot department ID. Okay, this one can be like a bit overwhelming, but to break it for you, it means that the department ID of employees is equal to the ID of departments here. So let's read it again. Okay, get me the first name, the last name, and the name, which is the department column name, from employees and departments, both tables. And how can you link those tables together? And you can match those records in one by the department ID of employees is equal to the ID of the departments. To make this less confusing, I will call this an alias name as department name. So this way you can understand that this name doesn't mean the employee name, this means the department name. Alright, so hopefully this one can be a bit clear. I will run this now and let's see what it gives us. If I run this now, you'll see that now we have the first name and the last name of each employee and the department name that they work at. And sure, to not begin being confused, department name is getting from the alias here. So yeah, what we have originally is the column name, which is getting from departments. And you will see here that now you know for each employee which department they work at. And if you want to make sure 100% that this one is correct, if you're skeptic, so I'm gonna add the department ID, which is, it will be from the employees. If I run this now, and you'll see that now, we'll see that for each employee we have the first name, last name, the department name, and department ID. So if you're like skeptic that, okay, is it correct? Does it work fine? Is it right? So you can take a look at departments, and for example, let's say for Malayos, it's marketing, which is department ID 2. Let's take a look. Is it correct? Like, is it working? Yeah, you see that. Okay, yeah, the department number ID is marketing. So this one works perfectly. And if I run this again, okay, it will take you some time because now your query is getting more complicated. So that's why it's taking a bit of more milliseconds. If you take a look now, so you'll see that for every employee, you'll see their departments.
There's a cool thing when joining tables together is that you don't necessarily need to use the whole table name. What you can do is you can give tables alias names. The same way that we do for columns, what you can do is you can give those tables alias names, so it will give easier way to mention the columns that you want from those two tables. So what I can do is, for example, we can say that from employees as E. So that means that, okay, E refers to the employees table. And for departments, you can use as D, which means that we want to use the departments as a D letter. So in this case, instead of saying where employees dot, we can say where E dot. The same way here, you can say instead of departments.id, you can say d.id. And this way, I suggest that you always use aliases when joining two tables, because, for example, if you say here first name, you may be confused by, okay, which table the first name belongs to. This one can be very simple because department's table only has ID and name, which can be very simple. And meanwhile, you can remember that if you have customers and orders, or you can have instructors and courses, sometimes names can be duplicate, and this will solve much of the problem. And you can be confused if any employee other than you is reading the query and they want to understand it without running it, it will be a bit confusing for them. So I always suggest that you use the aliases before each column name. So yeah, you can't, even you, after running again into this query after, let's say, 6 months, and believe me that sometimes you may need to return to your old queries if you're working and you need to read it. And yeah, you may, like, split your hair because of it and you couldn't understand what the hell is it doing. So you can use E dot here, so you can understand that it's from the employees table. The same with here, E dot last name. Here the department ID is also from employees, and you can know that name is from the department. So when someone reads name here, and I know that, okay, the name is a bit clumsy and it should be called department name. But anyway, for departments, it's quite straightforward that, okay, in the departments table, the column name refers to the name of the department. But here, since we join two tables, it can be confusing. So now, when you see d.name, it refers to the departments, which is much easier. Alright, so if I run this again, and you'll see that it will work perfectly. And here you go, it runs like a charm. And again, so for example, if I want to add the department's ID from there, like I want to use the ID from the table departments, and in the same time I want to mention the employee ID from the ID of the employee in the same query. So you see that departments and employees have a same name, which is ID, but it has different meaning. So if I just type here and I say ID, you'll see that if I run this, yeah, SQL is confused because ID is ambiguous. And you'll see that a lot if you don't use alias names. If you're joining two tables or more together, and those two tables have the same column name, and you want to select that column, either in the where statements or in the select statements, yeah, it will return an ambiguity error because, okay, this ID column, does it refer to the employees or the departments? It doesn't know. So you need to mention that. And sure, this works both in the select statements, and if you go here and I say, okay, and ID is equal to 70, which, okay, I want to see the employee number 70. So you'll say that also it's ambiguity. So the thing is, when you use any of the columns and two tables or more have the same column name, it's best to use alias names or the tables names, whatever you like. So here, when I say e.id, it means the ID of the employee. And to make yourself much easier reading that, you can use alias names for columns. So as employee ID. So you can see how this can make much difference for your query, and it can be better readable. And if you read it now, so you're selecting ID from the employees table and you call it employee ID, and then you have the first name, the last name from employees and department ID.
while you're getting the name of the department from departments, and you call it as an alias of department name. You see that how things can make it more clear. I know it can get like your query is getting bigger and getting harder at first and longer, but you'll see that later on you will get used to reading queries as fast, and this can save much trouble. And I'll show you the same in where, and here e.id is equal to, let's say, 70. So here what happens is, after joining those two tables correctly, and it show me the employee, that means that, okay, I want to see only one employee, but yeah, I need to join those two tables because I need the department name regardless. So this query is quite legitimate. For example, if, okay, I want to see only one department, so what I can say is, and the d.name, which means the name of department, is, for example, I want to see all the employees from the IT department, and you'll see that I am filtering the departments here. So if I run this, you'll see that now I only see the employees from the IT department, and you'll see that it's correct because all of those employees have the department ID 3, which is the IT department if you check the department tables. Finally, we're going to start to insert, update, and delete records from our tables in SQL. The HR has asked us to add the following information for a new employee joined the company lately. The information includes the ID, the first name, last name, the state, department, job title, and base salary. So we have Pete Klein, who just joined us as a technician from Georgia, and his base salary will be $1,800. Let's see together how can we insert Pete's data into the employees table. Now we're going to see together how can we insert a new record into our table employees. First, let's check together how many employees do we have so far. For now, we have 393 employees, which we will add another one today in this video. So how can we insert a new record into any table in SQL? First, we're going to start with a keyword, which you can guess it. It's called insert. And then we're going to say into and what table that we need to insert the new record on. For our case, it's going to be employees. So I'm going to say that insert into the table employees the following information. Please note that into is a mandatory keyword along with insert. Next, we're going to open a new parentheses and we're going to add the records, the record fields that we want to provide the SQL query with so it can insert the data into the new record. So first we're going to start with the ID, the first name, the last name, the states, the department ID, the job title, and the base salary. Another look into the presentation slide again, and you will see that those are the values that we need to add for Pete Klein. As you can see, we have 7 fields that we need to add, which I just added into the query. You'll see here that so far what I did is I only specified what fields or what columns that I want to add into. I didn't specify the values yet, which I will do just now. Next, we're gonna say values, and we're gonna open new parentheses, and here where we can provide the values for those fields we just specified earlier. Please make sure that the values should be in the respective order, the same as the fields that we specified. So we will start with the ID. The ID should be 394, which should be a new ID in our table. If this ID exists in our table, it won't work because this one is considered a primary key, and for us primary keys shouldn't be repetitive. We can explain this later when we go to the section of creating tables.
So the ID will be 394. It will be an integer, so I didn't use the single quotes as for the varchar or string. The first name, sure, what we need to do is we need to use the single quotes as usual when working with strings and characters. The name will be Pete, and the last name will be Klein. Next, the state will be Georgia. So for Georgia, as in our table, we use 2 characters to specify the state for each employee. For Georgia, it will be GA. Next, the department ID. If you check the values, I'm gonna check it again. Here are the values, and you see that department ID will be number 1. The job title will be a technician, and the base salary will be 1800. So I'm gonna say for department ID will be number 1. For the job title, it's gonna be a technician. And for the base salary, it's gonna be $1,800. Checking again the values, as I mentioned before, the columns or the fields in the first line should be identical to be the values to the second line. So the ID is going to be 394. The first name should be Pete. The last name should be Klein. The state is going to be Georgia. The department ID is going to be number 1. The job title is going to be a technician. And finally, the base salary is going to be 1800. Please make sure when you write your query that the values are identical, or it should be like, in respective order to the fields and columns that you mentioned here. You don't have to go into the same order that I did here. Like, okay, you can switch between last name, first name, or between the department ID and job title. It's totally fine as long as the values here match the fields names in the first line. Once you're all good, you can run this query and we'll see what happens. I'll run execute, and boy, this works. What it says here is that the query was executed successfully and the affected rows will be number 1, which means that we have one record or one row has been affected. For our example here, since we inserted a new record, it says that one record has been inserted into the table. That's great. Perfect. Please make sure that you run this query only once. Now, we're going to check together if now the new record has been successfully inserted as what it says here. So I'm gonna select from employees where the ID equals to the new ID of the new recruit 394. I will select this because I only want to run this chunk of query. I will run this and we will see that, wow, really, like Pete Klein is in our table employees. And you will see here that the values provided in our insert query has been successfully been inserted and added into the table. You'll see that the states, department ID, the job title, and the base salary has been successfully inserted. Okay, what about the other fields like the address, the zip code, or the phone number? What about those? For those, you see that we didn't provide any values for those, so they got the default value, which is null. And as we mentioned before, the null value is like the nil or the empty value, let's say, for any field that we have. It's like when you have a spreadsheet, and for your spreadsheet, when you open a new one or create a new one, the default value will be an empty cell. So the same here for relational databases. The default value can be an empty field, which is null, unless you specified a different value when you create the table, as we will see in the next section. So congrats, you inserted your new record. Perfect.
So we're starting now to see how can we modify our table values to change the values of any table, any record, or any field that we have. So yeah, this is the first perfect step for us. What would happen if you run the insert query twice? In my case, on the employees table, if I run this again, PostgreSQL will return an error that there will be a duplicate key value for the employee's primary key. We're going to talk more about primary keys later in the next section. For now, what we mean is for employee ID, it shouldn't be a duplicate values in this field. So when we added Pete's client as the value or ID 394, you can't add another record with the same ID anymore. So you need to change it. This one can be very useful if you want always unique values or unique ID for each employee. So this one of the many benefits of SQL in general, and this is called a constraint. So if you try to run this a second time, it will return an error, which is a good thing for our case because we don't want more than one employee to hold the same ID. Anyway, what I want to show you now is it's not necessarily to add that field's name or column's name when you run the insert query, which can be a bit tiresome or burdensome, especially if you have many columns or fields to specify in the query. On the other hand, you need to make sure that you need to add all the values for all the fields in your table if you don't specify the fields in the insert query. Let me show you an example. I will remove this and I will tell you why later, but I will remove some of the characters in the technician word and I'm gonna run this again. And yeah, before that I will do the same mistake. I will change the ID to 395. So as an example, so remember 395 is the next record. If I run this, it will run successfully, and let's check it out. So we added a new record with the ID 395. We don't care about the values for now, but what I care is I'm going to show you what happened. If you don't specify the column names in the insert query, SQL will take care of adding each value in the insert query in the respective fields in this table, which means that if you see that the ID, the first name and last name, will be put into ID, first name, last name, in the same order as you can see here, which here it was a right thing to do. It was correct. But now you'll see that things can go south and okay, the values are not correct anymore. For example, we have the state, which is supposed to be Georgia. Here you will see that SQL added the value GA, which is Georgia, into the address. Why is that? Because you didn't specify that GA for Georgia is the state. So SQL assumed that you're giving the values based on the order of the fields and columns for the employees table. So it added the first value to ID, the second value to first name, the third value to client, to last name, and the state to the fourth column, which is address here. Okay, going more to the state, you can see it was the number 1, which is incorrect for sure. Then zip code, which is okay, technician, which is why I removed some of the characters because zip code is restricted to 5 characters. Anyway, and the phone will be 1800, which is quite, nonsense. This is why we specified the name of the fields and columns in the last video. So if you're too lazy and you still don't want to specify all the column names, what should you do in this case? This still works, but what you need to do is you want to specify a value for each field and each column in your table. Okay, to do that, what we need to do is we need to fix this query so it can add the values in the right order for, let's say, a new ID which is 396. I'll keep P client since we will delete those records later. We will see in the next videos. Anyway, so what I want to do is I want to add the new record but in the right order without the need to specify the column names. So to do that, we need to add a value for each field, and we'll start with the ID. Next, you have the field first name, which is going to be Pete. The last name is going to be Klein. The address, which we don't have so far, so we can either use a single quotes, which can specify that this one will be, an empty string, or better, we can use the value null. You can use the value null as any value, as 0 or as anything. It's a value in the end, so you can use it in SQL when you run your queries. And you can remember that in the filtering section, we used null to filter values, specify specific values that time. Anyway, so I'm gonna give the address as null. The state is gonna be number 1. So here we're gonna change a bit, and I'm gonna remove this one and add it here. Since in our table the state, this is on a department ID, my fault. So the state was gonna be Georgia. Ignore what I said earlier. Next, we'll be having, after the state will be the zip code, since we don't have the zip code for now, so it's going to be null as well. And for the phone, also a null. Next is the email, is always null for now. And the hire date, this one can be good. We will check later how can we fill that. Okay, next what we're having is the department ID, which was number 1. Here you go. Next is the job title. We're gonna fix this to technician. Okay, and we have the base salary, which is gonna be 1800, and last is gonna be the commission. Okay, the commission I'm gonna add for 0, for example. Okay, for now, or you can add null, whatever you like. Okay, so if I run this now, as you can see here, what I did is I didn't specify any column names in the insert query, but on the other hand, I added a value for each field in the employees table. So you either specify what columns for the values to be added to, or you give a value for each column in the table when you insert a new record. Let's run this, and you can check it out that it was successful. And just remember, it's 396. You can give any ID as long as it doesn't exist in the table. So let's check it out now. We can run this, and that's perfect. So you can see now that comparing between 356 and let's compare between the two. So I'm gonna say I'm gonna say 395 and 396. If I run this, when we compare between the two, what we did in this video, the first one, the values will be added, like as you can see, by order, which it wasn't what we wanted. So we give null values for the columns and fields that we don't have the values yet. So here you can see that it's fixed. And I'm gonna add 394, the one that we inserted successfully with the field names in the last video, and you will see that 394 and 396 are identical and they're correct. So they're matching about each other. Meanwhile, the 395, which it was the incorrect one, the values have been added, in the same order. So as you can see, always do what we did in 394, which you can specify the field's name, or what you can do is you no need to specify the record, all the fields and all the columns, but you need to provide a value for each column in this case. So you have two ways to insert a new record into your table. Just remember this. The new recruit has provided us the rest of his information upon his orientation. This information is the address, the zip code, and the phone number. The HR sent us those information along with the hire date, which is going to be today, and the commission, which is 0% for now since he's a new employee. Let's see how can we update the new employee's record in our table. Okay, now for more fun. Since you remember from the last video, we added Pete Klein as a new record for our table employees. To remember you again, if we run select star from employees, where the ID should be 394, which is the one that we're going to update now. You'll see here's Pete's data, and you'll see that some information are still missing, which is the address, the zip code, the phone number, email, and hire date. Let's see how can we do all that. We're gonna start with the address and the zip code and the phone number. So to do that, we have the keyword which is called update, which is it says by itself that we want to update records in a certain table. So after you say update, you mention what table that you need to update or you want to change. For our example, it's gonna be employees. So we're gonna say here update the employees table and then set those values. So we're gonna come here, and for each field and each column in the table, it's not necessary here that you need to specify each field here in the table. In the insert one, since we need to add the values for the new record, you either specify the fields names, or what you can do is you can add all the values altogether. In the update, there's no need for that. You just specify what field and what column that you need to update, and you provide the new value for it. So for example, here we have the address. So I'm gonna say set the address to this value. So I'm using the equal sign here. The equal sign here is not the equal that we have in the where clause or where statement. It means that assign the new value to the column name, which is called address. So here I'm gonna say address. I'm gonna check the address from here since I can memorize it. Here we go. So I'm copying from here. It's gonna be 2826 Clement Street, Atlanta. We can use the comma as we mentioned. Now for each column that you separate the column with the value by an equal sign, and you separate between the different columns with the comma sign. And here, since it can be more readable, I'm gonna add a new line here. And always remember, in SQL, it's case insensitive, except if you're working with varchars between single quotes, and it's no matter what lines you add, you can add as many lines as you want, and it still works, as long as you don't separate those with a semicolon if you're running more than one query. Anyway, so next is going to be the zip code. The zip code based on the details is going to be 30303. This one is easy. Here you go. And the last thing is the phone number. The phone number, remember, in our table, it's a varchar. It's a string. It's not a number. So I'm going to copy it, and here it is. And going here, and I'm going to use it here and paste it. And make sure that it's between the single quotes. So for now, we're gonna add those three values since they're the easiest for now. It doesn't mean that the rest of the values are hard, but we can do it in, eventually. I don't have to bring all the values together. So to show you that, okay, you can update as many columns and fields in one query as you want, or you can take it easily. So this is what we have been so far. And here, I was about to do a very big mistake, but yeah, I just remembered now. The thing is, you need to make sure that when you update a table and you set the values, you need to specify what records those values will apply to. Here, if you run this query now, something very funny yet very bad will happen, which all your records will get those values. And I'm gonna run this in the next video, but not in this one, to show you what happens. So here, you need to specify which record those values should be applied to. In our case, we need to apply it on the record with the ID 394. So here you should say where the ID is 394. And now this is the query that we need to run. What we did here is we told SQL to update the table employees with a set of values for the record whose ID is 394. Please remember this one. If you don't remember this, your table will be all messed up, and I will show you in the next video what would happen. Add it for now, and let's run this. If I'm gonna run this, and it says it's executed successfully with affected rows, which is 1, and this is quite important for the updates, and that we have only one record which was affected. Now let me show you how is the state of our new employees record. So where ID 394, and you'll see now that the address is what we specified, 2826 Clement Street. The state is Georgia. The zip code is 30303. For the update query, you can run it as many as you want, and it will give the same value since you didn't change any of the values here, and it will be affected only one record. If I run it again, you'll see that here it is. And as you can see, the rest of the values before, they're not affected. So he's still a technician, he's still having the base salary, and yeah, that's it. So he still has his first name and last name all. So we saw now together how can we update the values of any field for any record that we have in our table. So you have it now. Enjoy. If you want to delete a record or a row from a table in SQL, let's say that we want to delete beat client from our tables for good with the ID 394. Just remember that in real life, actually, companies, if we want to delete a row or a record from our table, let's say we want to delete beat client from our table employees here with the ID 394, we can do that in SQL actually. In real life though, it's not common to delete data from tables. What we do is we mark any record as deleted, let's say. Now with the age of data is quite valuable. So instead of deleting data, they just if they have data which is expired, they just mark it as expired with a date. For example, for beat client, they don't delete the data for beat client. What they do is they mark the resignation date, let's say. So they know that this employee has left the company, but his record is still there. And yeah, it's the same for any company that we work now. So anything that you do on the internet is being recorded and not deleted actually. Yeah, I know it's spooky, but this is how it works now. Anyway, so the delete record, you won't use it much in real life, except if you're doing, some training on your data, you're a data analyst that, okay, you need to clean your data or remove some records that you don't need in your data set. Anyway, to delete data, what we're gonna do is, you can guess, it's a keyword of delete. So what you're gonna do is delete from, and you specify what table do you need to delete from, which is employees here. Here, we want to specify what record do you want to delete. And in this case, we want to delete the record with the ID of 394. Now, some people may ask, is it always that I need to use the ID in order if I want to delete or update even? In the examples here in my videos, I used only the ID. Why? Because it's the easiest. It's easier, or it's much better to use the ID, which is a unique value, than using other values which can be duplicated. Okay, first name, for example, Pete, maybe, okay, I don't know, in my database or my table, maybe more than one have Pete. But I can show you another way, so just to make sure that, okay, there's different ways. As you did for filtering using the select statement, you can also use it in delete, use it in update as well. So here I can say, okay, delete all the employees where the first name is Pete. So here it will delete all the employees with the first name of Pete. And if I want to be more specific and I want to delete Pete Klein, I can say where first name is Pete Klein and the last name is gonna be Klein. So here it's like another way if I don't know the ID, which is, yeah, quite, common or quite reasonable, since I can remember all the IDs for the employees, but I can't remember their first names and last names. So I can use first name and last name in this case. And what I say here is, okay, delete from employees all the records with the value of first name Pete and the last name of Klein. If I run this now, it will be successful and the affected rows is 1. And this one is quite important to know. The affected ones means the deleted ones, which is 1. And now if I look for the ID, which is 394, it should be deleted. Yeah, as you can see, there is no results. And to make also more sure, I can say where first name is equal to Pete and Klein. There is no one. Okay, for fun, let's see if we have Pete. No one. So, anyway, I only had Pete Klein, who was deleted using this query. Again, what if I don't use the where clause? Let's try it out. If I run delete from employees, wow, okay, the affected rows are 393 rows, okay, it looks scary a bit. If I run select statements, okay, I don't have any records anymore in our employees table. Wow, this is so scary. Okay, as you can see, if you run the delete statements without any where clause, it will delete everything. So this is a quick and very quick and dangerous way to delete your records here. If you want to delete everything, you can just delete from what table, and that's it. So when using delete, you need to be very cautious and you use the where clause as well. Again, don't fret. If you run this, you can recover the data using the attached file. So you can recover all the data that we've been used for. But sure, Pete Klein won't be. I didn't add Pete Klein, so you can add it manually again, and you can try it out by yourself. In this lecture, we're going to start to create our own tables in SQL. Let's say that we have this spreadsheet for book titles from a bookstore, and they want to move this spreadsheet into a database. If you can take a look at the fields first, you'll see that we have the ID, the title, the author, publish year, price, and last update. In this case, what we want to do is first we need to identify the data type for each field or column in the spreadsheet in order to create a table which can help us to move this data or to insert this data later into that database or table. Let's see what data types SQL provide us first. Let's take a look at the data types available in SQL. In general, we have 3 main types: character, numeric, and date or time. For characters, so we have several types, and for numbers, we have either the integer or real ones. And for date and time, we can either store the date only, or we can store the whole timestamp, or the date and time together. Unfortunately, from here, what we're going to see is there are differences in the acronyms for data types between different databases. Means that what we can use this in course, since we're using PostgreSQL, may be different for other relational databases, such as MySQL or Oracle or SQL Server. I'll try in this course to cover up as most as possible for different data types and what is the difference between those relational databases. In this course, we're going to follow what PostgreSQL has and the syntax as well. So if you follow me in this course, you need to apply those queries on PostgreSQL. If you try to do it on other relational databases, it may return an error, so you may have some problems. Okay, let's cover what character data types do we have first. If you're going to take a look here, that you'll see that we have varchar, char, and text. What is the difference between those two? Let's start with char and varchar. The difference between the two is about allocation of space in the database. Means that when you define a field as, let's say, 10 characters, which means that it will take 1 byte if it's ASCII or 2 bytes if it's Unicode. Without going further details in that, what we care about here is when we say that we want the field to be of char or character data type, which is the second one, it means that if you define the maximum length of the field as 10 characters, let's say, it will store 10 characters or 10 spaces for your field in this case. Meanwhile, if you go and define your field as varchar, which means variable character, the great thing about it is it will allocate exactly the size of the field value instead of the max field value. Means that if you allocate 10 spaces or 10 characters to your field and you stored only 6 characters, for example, varchar will only store or allocate exactly 6 spaces or 6 characters for this field value. This saves much space on your database, and sure, because in this course we're using small data sets, so it's totally fine if we either use character or varchar. But you can imagine if you have millions and millions of records and fields, how can the data can be big, quite quick in this case. And you try to save more space, since databases, while now drives and hard drives become cheaper and cheaper, but the data also become bigger and bigger. So it's best practice to use varchar in this case. As for text, the difference between varchar and char or text is that for text, it's best used when your field has over, let's say, 250 or 500 characters. And this is very useful when you use for comments, product descriptions, any of that. So always use varchar if your field length is below, let's say, 250 or 500 characters. Otherwise, use text in this case. Now the difference between PostgreSQL or other databases and SQL Server, for example, is that SQL Server calls char and varchar as nchar and nvarchar. So if you're using SQL Server and you want to define a data type for your table, on SQL Server you need to use nchar and nvarchar instead of varchar or char. And in Oracle, you need to use varchar too, since they have 2 versions of varchar, depends on the data type that was defined in Oracle as a product. So yeah, it's different from PostgreSQL and other databases. Keep this in mind when you use and you define the data types for your tables in any of those 2 databases. As for numbers now, we have the numeric values, and here we have several types that SQL provides us with. We'll start with the main one, which is the integer. So integer, or the acronym is int, it stores negative and positive numbers without floating points, as the numbers that we use usually, like product, let's say count, or let's say for stock or for years. So any numbers without any floating numbers, it can be floating point, so it can be stored in the integer data type. The integer data type, it can either use the full name or you can use the acronym, which is int. So int, which you'll see it a lot more than the full name integer. SQL provides several more, like small integer and big integer. The difference between integer, small integer, and big integer is about what is, the size of the allocation, or let's say how many digits can it hold. For example, for integer, it can hold between minus 2 billion to positive 2 billion. For small integer, it's a lot less, the range, which is between minus 32,000 and positive 32,000. Big integer will hold trillions, I guess, or even more. The number is quite huge. That's why when you store numbers, you need to know what will be the range of your values. If it's sometimes for a small retail store, that okay, maybe the most expensive product can be of $1,000 or something. Yeah, small integer can be enough. If it's about in general, people use integer as it's 4 bytes. Big integers can be used, for example, for banks, since they can store billions or even trillions of values in there. The differences between those three are the space allocation that they can get into the database. So yeah, it's best to know what is the range of your values, and in this case you can store you choose the data type that suits your field. Now we talked about integer. Now we have float numbers, or real numbers, let's say. Float or real numbers are the numbers which are of floating points. Anything can be, for example, amount. The amount usually, especially in the West, it's used in decimal numbers or in floating points. So especially that we have 99.99 or 99.99. That's sort of values or amounts you see usually in the retail stores or online. So the float numbers is used if your field value has floating points. Otherwise, you can use integer to make it simpler. Anyway, so for floating points, we have several types as well that SQL provides. The first one is float, and the second one can be either real or double. It depends really on the type of database. It's either MySQL, PostgreSQL, Oracle, etc. So you may say real, or you can see double. And both means that they store floating points for real and double more than float. So for example, I'm not sure exactly how much, but if float data type can store up to 10 digits of floating points, real and double can store double that, which is can be 20 floating points. This one can be really useful for chemicals or for any operations that needs extra accurate floating points for their numbers. For example, let's say for maps and for any type of data value that needs 20 or 30 or even 50 floating digits at the floating points in this case. Next we have the decimal or the numeric data type, which is this one is more general, means you can define how many digits before and after and on the right and left of the floating points. Means that if you want to store 1432.93, so in this case you have 4 digits at the left of the floating point and 2 digits on the right of floating point in this case. So here you can be more specific. How many digits can you have in your data type in this case? Last is data in time. We saw that before when we did the conversion, if you followed the lectures before. And anyway, so what we have in SQL is we have dates, which stores only the dates of the day. And we have either the timestamp or date time, it's called. It depends also on the database that you're using, if it's PostgreSQL, MySQL, Oracle, SQL Server, etc. In PostgreSQL it will be timestamp. In MySQL I think it will be date time. So yeah, take note of that. So for timestamp, the difference between timestamp and date is that timestamp also stores the time. So this can be much more accurate if you want to know not only the date but also the time. For dates, you can use, for example, date of birth. It can be enough if you only need the day. But for timestamp, you can, for example, the time when, the employee arrived, for example, since they care about which minute or even second they reach the office. In this case, you can choose which data type of date or even timestamp or date time is suitable for your field value. Since we covered together what data types SQL provides us, let's see how can we apply those data types on the current data for the bookstore. Let's start with ID. As you can see, ID is of numeric value, so it can be a number, not a string. Sure, you can use numbers to be stored as characters, but it's for best practice to store numbers as of numeric values instead. It can be faster when you query those values later in your database, especially that when you have millions of records later. So the SQL doesn't have to convert the number from string to numeric, so it can do the needed equations or formulas later on if you do any complex formulas on your numeric data. Anyway, so ID, I guess it will be best to use as integer for now. We may use small integer or tiny integer or any type but we can stick to integer for now. So we're going to define ID as an integer. Next, for title, as you can see, title is of characters, so it's best to use varchar in this case. So we have varchar, and next for varchar, we need to define what is the size of it. So let's say that we can use 30, for example. So I'm going to use 30 characters as the length of the title here. We're going to see if it's enough or not. For author, it's the same. So since it's of characters, so we can use varchar as well. And we can define it as 30 characters too. Next, we have the publish year. As you can see here, the publish year is a number. So you may say that, okay, we can use date here, but since we only need to store the year, there's no need to store the whole date. It depends really on your case. In some scenarios or cases, you need to store it as a date, so it will be called publish date instead. Here in our data, they only store the year, so it's enough to use integer in this case. You have the freedom to use any data type that you find suitable, depends on your data. For price, you see that for prices they're a bit different. We can use integer because here we need to store floating points. As for the prices here, you see that we have 0.9, 0.9, 0.9. So in this case, instead of using integer, we need to use either float or real. And in this case, we're going to use float since it's more than enough for us. Finally, it's last updated. You see that for last updated, it's a date and time or a timestamp in PostgreSQL. So date won't be enough because we need to store the time as well. So it's best to use timestamp in this case, or date time if you're using any other database. Depends on what database you're practicing on. If you're following this course, we're using PostgreSQL, so it's best to use timestamp. Perfect, so we see what data type each field and each column in our spreadsheet has. So next what we can do is to start querying and create our own first table. In the last lecture, we defined what is the data type for each field in the spreadsheet. Now we're going to create our own first table in SQL. Let's start. Going back to the SQL client that you're using, we are going to create our own first table in SQL. So to create the first table, we're gonna start with create, which means that we want to create an entity. What entity is it? So it will be a table, so we're gonna create a table here. So we're starting with create table, and we need to name our table. Since the data that we're gonna store is of books, so it's best to call our table books. And it's best practice to always call your tables on the data that it fills. So for other employees, coworkers, colleagues, students, they can know what type of data this table stores. And we use the plural form of the entity that we're storing in this table. For example, if it's books, so we can use books. If they are employees, we store the employees. For customers, we keep it customers, orders, etc. So always keep it plural. It's one of the best practices as well. Next, what we want to do is we want to define the data types this table will have, which means the fields or columns that this table will hold. So first, you need to open parentheses. And to make the query more readable and easier to understand and read, I'm gonna leave some space here, so the query can look prettier. So in each line, we can define what is the column name and the column type. So the first column, if you can remember, let's take a look at the spreadsheet. You see that the first column is going to be the ID. The second column will be the title, author, published year, price, and last updated. Getting back again, here the first column will be ID. So I'm going to call it ID, and I'm going to leave a space, and next I need to define what is the type of ID. As we discussed before in the last lecture, the ID is going to be of type integer. So I'm going to use the acronym INT. That's it. Here we defined our first column in our first table. We leave a comma so we can, separate between the columns that we have. And I'm going to leave a space so it can be more readable. I'm going to define each column in a separate line. Next, we have the title. So I'm going to call this field or column as title, which is self-explanatory. And here, as we discussed, the title is of character type. So we're going to use varchar. Next, what we need to do is we need to say what is the maximum length of title. And I'm going to use 30 for now. So here what I did is I defined a title, which is a column of varchar, and with maximum length of 30. If you're asking what is the maximum length I can define, it depends really on the database you're using. For PostgreSQL, I think it's 65,535, something like that, or 536, yeah, something like this. So as mentioned before, if your character type is too long, you can better use text or long text. It depends on how many characters you need to store. Next, the author. We have the author, which is also varchar because of its character, and we'll stick to 30 for now. Next, what we have is the publish year. The publish year here, since we're using two words, which is publish year, what I like better is to, instead of using spaces, and this may make things pretty ugly later. Sure, you can use you cannot define two words like that. You can call like, yeah, okay, I want to publish here and of type integer, for example. SQL will return an error. Instead, you have two options. First option, if you want to keep the space between publish and year, you need to use double quotes. In this case, SQL will understand that publish year in two words will be the field name or the column name. This can also be ugly later, since when you need to do querying, you need to use double quotes every time you query for this column. So instead, people like to use underscore in this case. It looks more niche, it's easier to query to later, and you can this way read the column very well, publish underscore year or publish here. And instead of doing it like this, which can be pretty ugly,
As you see here, publish here in one word can be very hard to read, so it's better to use this way, publish underscore here. As we mentioned before, publish here is going to be integer in our example, so we keep it like that. Next we have the price, so we're going to define the price, which as discussed will gonna be a floating point, so we're going to use the data type, which is float. Finally, we have the last column, which is updated. So we're gonna say last and updated for the name of the column. And as we mentioned before, it's better if your column is of 2 words or more, you can use underscore. So last updated, which is much better. And this one is going to be of type timestamp or datetime, depends on what database you're using. So that's it, perfect. So here is how do you define your table in SQL and how to create one. So to recap, we say create table, we name the table as books or any name that you like to name it, can be cuckoo, whatever. And then you can define the fields and columns that you have in this table along with the data type. And the data type is mandatory here. So each field, when you define it, it has at least a name and the data type. Other than that, it's all good. You have more options later on we can cover in this course, but this table and this query is more than enough to create us our first table. I'm gonna execute it now. And it says that the query was executed successfully. And here you created your own first table in SQL. To make sure that the table has been created, let's try to query it, which means that we can select star from books. I'm going to execute this. And here you go. It says that it finds no results because the table sure is empty for now. But you can see that we have all the columns that we defined in our previous query. The ID, the title, the author, publish year, price, and last updated. So next, we're going to use our table to insert some data and see that if our table really is in our database, and we can now store and insert data into our own first table in SQL. After we created our table, we want to insert some data into it. So let's do it. To insert data, we say insert into, and we say which table to insert, which is books in our case. And since here we want to insert into all the fields of this table, we don't need to identify those fields that we want to store into. We can directly go to values, and with opening parentheses, we can define the values that we want to store in. So first we're going to start with the first book, which is called Emotional Intelligence. So the ID is going to be 1, the name of the table, the title of the book is going to be Emotional Intelligence. Sure, you can insert it as what you wish, so you don't have to follow me. Next, what we have is the author. The author is going to be Daniel Goleman, and it's going to be the publish year was 1995. The price is going to be 9.9, and finally the update time or last updated. Since now we're going to insert this record for the first time. If you can remember, there is a very cool function that gives us the current timestamp for the database, which was the function now. So to call now, we call the name and we open empty parentheses. Those parentheses so it should be, because it's now is a function, it's supposed to be for sending arguments, but since now takes no arguments, so we keep empty parentheses. To revise it again, you see that for ID I send it as an integer. So I send it as without any single quotes. Sure, you can send it as single quotes, no problem. And SQL can auto convert it into an integer. But to make our database less busy, we can set it as a number instead. Emotional intelligence, since it's a varchar or a string, we send it between single quotes. The same for the author. About the year, which is an integer, we send it as numeric as well, without any single quotes. And for the price, since it's floats, we send the floating point 9.9. All good. Let's try it out. And here we go. It was executed successfully. And let's see now if we run the select statement. You see that now the data has been inserted and stored in our table called books. You see that we have the ID, the title, the author, publish here, price, and last updated, which is today or now in my case. Perfect. So we can move on and insert the second one. I'm gonna copy this, or I'm gonna type it again. Insert into books, now to the next book. The next book will be Harry Potter and the Order of Phoenix for J.K. Rowling, published in 2003, and the price is going to be 11.9, and sure, the last update will be now. Let's go back, and I will give it the ID number 2, and I'm going to say Harry Potter and the Order. Let's use that. The Order of the Phoenix. Not sure if this is right. Sorry. Okay, to make sure. Yes. Alright, perfect. So next is gonna be for the author, J.K. Rowling. And next, the published year, it was 2003, as far as I know, and the price is going to be 11.9. And the same, it's gonna be now, so we can store the current timestamp. I'm gonna run this and we'll see what will happen. Oops, so we have an error here. What does it say is the value is too long for the type character varying, which is the varchar of 30. As sometimes it may be difficult, and this is the problem with SQL. Here it doesn't say which column has exactly the problem, which sometimes you may like wondering what is the exact error here. But for starters, let's say that we have a problem with one of the fields that the value that we're sending into the insert query is too long. It means that for a field that is 30 characters, it cannot store the value that is being provided in the insert query. If you can see here, what it actually means that this value of the Harry Potter, the title value which we're sending here, Harry Potter and the Order of the Phoenix, is actually too long for the title, which is only, as you can see here, it's only 30 characters. Meanwhile, for this one, we can see how many characters. I'm gonna copy it and I'm gonna use a very useful function called length, which can help me count how many characters here. If I run this, you will see that it's 41 characters. So we're trying to insert a 41 character string into a title or into a field which has only max 30 characters. So that's why you see that SQL returned an error and it couldn't insert this record. And if I select again, you'll see that the record wasn't inserted. Yeah, this one is from the query before, but the new book wasn't inserted due to this error. And even if I run it again or 1,000 times, it won't be inserted. What we need to do here is we need to fix the title to store more than 30 characters. So what do you think? Do we need to drop the whole table and we create it again? It can be an idea that, okay, you can fix this and you can give it, for example, here 100 or 1,000. But the thing is, you need to insert your data again. Since here maybe you have only one record or one row, it's okay, but you can imagine if you have
thousands or millions of records in your table, it won't be a good idea to just drop the table and create a whole new one with changing a single column and then insert the data again. There is an easier and faster way to do that, which we'll see in the next lecture. In the last lecture, we saw that we couldn't store the full title of Harry Potter into our books table because the title was too long, which was over 40 characters. Meanwhile, the title column can only store 30 characters based on how did we define the table books when we created it. What we want to do is we need to modify the table structure so it can hold over, let's say, 40 characters or even 100 characters. So to do that, we want to use the keyword alter, which means that we want to alter or modify an entity structure. And this entity this time is going to be a table, and the table is going to be books. So we say alter table books. Here when we say that we want to modify the structure of the table called books. Next here when things can be different also between relational databases, PostgreSQL has a different syntax from Oracle, MySQL, and SQL Server, for example. So in this case, if you're using PostgreSQL, you can move with me and you can follow me. If you're using any different databases, you need to check what is the syntax for each SQL query that we're gonna use from now on. Unfortunately, it can be a little bit different. I'm gonna try to cover what the differences will be, but I'm gonna stick to PostgreSQL in this course from now on. Anyway, if you can follow at least and you can have an idea of what you can do in SQL in general. So the syntax can be only a secondary thing as long as you can understand what SQL is capable of. Anyway, so here what we want to do is we want to modify the data type of the title column to be from varchar of 30 characters max to be of varchar but of 100 characters. So here we're going to start with alter again. So it means that I want to alter or modify column. So alter column. I want to specify what column do I need to alter in books table, which is title here. And I want to specify what type of change is being done here. And here what I'm changing is the type. So I need to say the type. Next, I'm gonna need to provide the new data type that I want for title, which I will keep it as varchar since sure, it's storing characters and strings, but I want to increase and expand the length of the field to be 100 characters instead of 30 characters, which was before when we created the table. This should be it. So to check it again, we say first alter table books means that we want to modify the structure of the books table, not the data. Just remember, if you want to modify the data, you can use update table books. Here, since we want to change the structure of the table, which is books, we can say alter table books. And then we want to modify or change the title column in the table books. So we say alter column, the column name, which is title, and then we say what type of change, which is the type. Like what kind of change, which is the columns type, and we say type, and we specify the new data type that we want for the column. Let's run this and see. And it says the query was executed successfully and the changes has been done into the books table. So now books table title is able to store up to 100 characters. Let's try again and let's insert into books values, and I'm gonna specify the values again. It's going to be publish year was 2003, fine, and we're going to use now to store the timestamp for now. And let's see now if you can insert it, and you can see that it was executed successfully. It could store the full title now of Harry Potter. To make sure that everything is okay, we can select star from our newly table, which is books, and you'll see now that you have two records, one for emotional intelligence that we inserted in the last lecture. The second one is for our newly inserted record, which is Harry Potter. And you'll see now, after we did the change into the title column by expanding the data type into 100 characters instead of 30 characters, so we could successfully insert the new data into the books table. So we saw together how can we change a type of a column in your table. This one can be really useful since, sometimes when you start creating a table, you started with some, max length of a small number. Then later on, you'll see that, okay, you need more. So you can expand it to a bigger size by using alter table books. Now you may ask that, okay, what is the difference between this and other relational databases? So the trick can be that for some databases, for like SQL Server, as I recall, they use modify instead of alter for modify the column. And for example, as I can recall, for Oracle, there is no need to say type here. You can directly say alter the column, which is title, and you can give away the new data type. So yeah, I can provide with a list of the changes that can be between different databases. But if you're following the PostgreSQL in this course, you can see that this is how it's being done in PostgreSQL. So all good.